şurada. Kabul ettiği Biz ölçüyoruz. Görüntü açalım. Merhaba. Buradan biz hello for everybody. Good afternoon.
Merhaba hocam.
Merhaba Sefa hocam, merhaba. Alperay da katılıyor mu?
Evet, katılıyor hocam.
Merhaba hocam.
I think we can start. Hello for everybody. Welcome to our session. I am Professor Mehmet Hakkı Alma from Iğdır University, member of Turkish Academy of Science in Energy Group with Professor İbrahim Dinçer. We have 6 presentation. First is, I think, will be done by Gizem Balmuk, I think.
No, actually me.
Really? Who are you?
I'm Cem Kantarlı.
And
also I have a second
presentation, isn't it? You have 2 presentations.
Yeah, in this session. Yeah.
Okay, Mr. Jam's title is Hydrothermal Carbonization and Wet Olive Meal Waste. Will be done, I think, 3-4 scientists. Most probably Ismail Cem Kartal, Mr. Ismail Cem Kartal will present. Please, we can start and be punctual. We have 15 minutes, including 15 and then 13, I think just 15. If you are ready, please go ahead. We can start our session.
I'm sharing the screen actually now. Just the PowerPoint first.
I think you can share by yourself as far as we get information from the organization office. Oh, okay.
It's okay.
Good.
Good afternoon, dear audience. I'm Cem Kantarlı from Ege University. I work as a lecturer in the Medical Technology Vocational Training School of Ege University. Today I will be talking about hydrothermal carbonization of wet olive meal waste as an alternative method for management of this waste. And this is the outline of my speech. I will first introduce you with the waste. Then I will talk about the properties of materials and methods we used. And I will give my results and my conclusion at the end. The process of oil extraction from olives generates large amounts of byproducts with a high pollution load. Around 3 million tons of olive oil is generated per year worldwide, and it's estimated that around 8 million tons of olive oil wastewater is generated annually, and olive oil is mainly extracted by continuous two-phase centrifuge systems due to their advantages such as energy and water savings. And at the end of the extraction process, the system generates oil and a semi-solid waste stream, usually called two-phase olive meal waste separately. And here are the photos of we have taken in the local firm that we borrowed to two-phase olive meal waste. They deliver the olive, they leave the olive, they wash the olive, they grind them, they form a paste, and they centrifuge the paste, and they extract the oil and separate it from the two-phase olive meal waste. This waste represents 80% of the total weight of the fruit process, and it consists of olive pulp, a considerable amount of water, up to 8%, and a variety of organic compounds, including fats, proteins, sugars, lignous cellulose, hemicellulose, pectins, tannins, phenols, and also inorganic constituents. It's described as a significant pollutant to surface and groundwater resources in the Mediterranean basin, and it has a phototoxic character in case of direct application to soil as fertilizer, due to mainly its high toxic phenolic content, colored organic substances, and high organic matter concentration. Therefore, its management is generally viewed as a disposal problem, and majority of the olive oil companies in Mediterranean countries lacks a comprehensive waste management plan. They usually add water to this waste for dilution and dispose it in sewage systems or in nature, damaging the local ecosystem. And forest treatments, actually environmentally sustainable and economically beneficial approach have to be developed, and several ways has been tried for its management or treatment, but these techniques had disadvantages specific to them with respect to their toxicity, low recovery, and high capital cost. As an alternative, chemical conversion process be the feasible solution. Conversion of this waste into energy by thermochemical routes such as combustion, pyrolysis, and gasification can be an option for its management. But actually, for application of combustion, pyrolysis, and gasification, the high water and alkali contents of this waste are the major drawbacks, since energy-consuming drying of this wet waste is needed, and also during their combustion and gasification, slagging, falling, or corrosion may occur as a result of its high alkali content. And alternatively, hydrothermal carbonization is another thermochemical method, can eliminate these drawbacks, since it doesn't need the drying of biomass for the process, and it removes water-soluble inorganics during the process. And actually, in the hydrothermal carbonization, it's applied to wet biomass, such as our waste, in aqueous medium, in the temperature range between 160 to 250 degrees Celsius, and at corresponding autogenic pressures up to approximately 2 megapascal in a closed vessel. It's applied in an oxygen-free atmosphere, and as a result of the process, carbon-rich solid product is obtained, which is named as Hydrocharge. And the main purpose of the study was to convert this waste into a solid energy feedstock, Hydrocharge, and the specific objective was to investigate the effect of process temperature and process duration time on the mass yield, fuel characteristic, and combustion properties of the obtained Hydrocharge. And when we look at the characteristics of our waste, two-phase olive meal waste, it has a solid content of 33%. It has a high heating value, calorific value, and it has a high potassium content. And also, when we look at component analysis, we can consider this waste as a lignocellulosic waste when it is dry. And when we look at experimental methods, actually, in a typical experiment, a mixture of 90 grams of olive meal waste and 90 grams of deionized water were loaded into this reactor, stainless steel, shaking autoclave with a volume of 500 milliliters. The tested duration time was between 0 and 240 minutes, and we tested the process temperatures between 200 and 260 degrees Celsius. When we loaded the mixture into the autoclave, we heated at a rate of 5 degrees Celsius per minute, and at the initial pressure at the beginning of the process was 1 megapascal, and at the end of the process, the reactor content was taken. It included an aqueous waste and hydrochar, and they were separated and from each other, and the aqueous waste was kept in bottles for further analysis, and hydrochar was first washed with 100 milliliter distilled water, and it was dried at 105 degrees Celsius for overnight. And the characteristics of the obtained hydrochars, we determine them according to the standard methods. We also determined the combustion property by thermochrometric analysis under oxygen atmosphere, and an organic composition was determined by ICP, and we, depending on the elemental analysis of hydrochars, we calculated the high rating value of hydrochars depending on this formula taken from the literature. And when we look at the hydrochar yields, we saw that hydrochar yield decreased sharply at low temperature with the change of duration from 0 minutes to 30 minutes, and for longer duration it didn't change much actually, and at higher temperatures hydrochar yields decreased. At higher temperatures hydrochar yield decreased for longer duration due to the secondary decomposition of hydrochar actually. And when we look at the carbon distribution of carbon in the two-phase elements among the products, we saw that around 75% of carbon in the waste retained in hydrochar, and the carbon in the gas phase increased due to the increase in gas production at 260 degrees Celsius, which was mostly carbon dioxide, and which was due to the degradation of organics in aqueous phase. And carbon distribution in aqueous phase remained almost unchanged within the temperature range. When we look at proximate and elemental analysis of hydrochars obtained, the ash contents of hydrochars actually were lower than that of waste, two-phase olive waste, due to the solubility of inorganics at subcritical water conditions. And volatile matter contents decreased, and fixed carbon content increase with increasing temperature and duration actually, and this enhanced this change in the volatile alternative and fixed carbon content, enhanced the fuel ratio up to 4 times actually. And carbon content of hydrocharge increased, and oxygen content of hydrocharge decreased as carbonization temperature increased and duration time got longer. And when we look at the fuel characteristics of hydrocharge, in parallel with the increase in carbon content and decreasing oxygen content, the calorific values of hydrocharge and thus their energy density ratios have increased. And the heating values of hydrocharge obtained at 30 minutes duration time in the studied temperature range we obtained were higher than the heating values of the hydrocharge obtained in the literature from the same wastes due to the higher carbon content of our hydrocharge we obtained in the study, and energy yields decreased due to the decrease in mass yields despite the increase in heating value with increasing temperature. Actually, the energy yields decreased due to the decrease in mass yields despite the increase in heating value with increasing temperature. And so we can say that the effect of time on energy yields varied according to the temperature. I have to be faster, I think. The increase, when we look at one prevalent diagram of hydrocharge to follow the process, the change in the atomic hydrogen carbon and oxygen carbon ratios, we draw the one prevalent diagram, and the increase in temperature causes a decrease in hydrogen carbon ratio and oxygen carbon ratio of the obtained hydrocharge, as can be followed from the diagram. And during hydrothermal carbonization, biomass degradation at low temperatures, the brown and yellow dots, as you see, seems to be occurring mainly by dehydration, but at elevated temperatures seems to change mainly by decarboxylation reactions, since mainly oxygen carbon ratio is changing, but hydrogen carbon ratio is staying the same. And as a result, when we look at the regions, most of the hydrocharge obtains are close to the lignite region, and lignite coal-like hydrocharges are obtained at low temperatures for long duration times and at elevated temperatures even for short duration times. And when we look at the combustion characteristics of hydrocharge, we see that the ignition temperature of hydrocharge obtained at 200 degrees Celsius is higher than that of the original biomass. But the ignition temperatures of hydrocharge obtained at higher temperatures
Please try to summarize because time is passing very quickly. Just
okay, decreased values significantly lower than two-phase orbital waste with the increase of duration. When we look at longer durations, seems to be lower than two-phase orbital waste, and this was attributed to the inclusion of the tar-like coated structures in hydrocharge that formed by repolarization of water-soluble compounds in hydrocharge. All hydrocharge had lower ignition temperatures than lignite given in literature. No linear relation between burnout temperature and hydrothermal process temperature and duration time were detected. And Finally, I want to give you the inorganic composition of hydrocharge obtained and compare it with the two-phase all-meal waste. Actually, the main inorganic constituent is potassium oxide as the major constituent, and the amount of potassium content decreases after the process, and around 95% of potassium in raw waste leads to the aqueous phase after hydrothermal carbonization, and the removal of these alkali oxides during hydrothermal carbonization of our waste raised the expectation of safer combustion of dried hydrocharge, and alkali index values of waste implied surface lagging and falling would occur, but on the other hand, the alkali index values of hydrocharge lower than critical value 0.17 implied that their combustion would be safe as expected due to the removal of alkali oxides. Thank you for listening. And my final conclusion, this process eliminated some of the disadvantages of our waste as fuel, but as fuel by converting it to hydrocharge with lower ash content and higher heating value, but it wasn't sufficient for enhancing the combustion properties, combustion characteristics. Thank you for listening, and it was supported by the study.
Congratulations, it was very nice study. I think the Professor Jale Yanık is also in your team.
Yes.
It's a very strong team, I know. Thank you very much. I hope we have some program in the future, in I think September, on the biomass energy. I plan to invite yours as well. I think we don't have time to get questions after the end of session. We will try to get a question. Thank you very much, Mr. Cem. It was very nice study. Just I have asked a very quick question. Did you measure surface area of your charge, gram per square meter, surface area?
We selected some of the charge, but it was very low actually, the surface area of hydrocharge.
Yeah, you didn't make any pre-treatment, isn't it? Just directly try to use hydrothermal system. Have you done any pre-treatment for carbonization?
Any pre-treatment? We keep the two-phase all-meal waste in the refrigerator, and when we are doing the experiments, we let it to come to the room temperature and start the experiments. And actually, 1:5 ratio, biomass to water ratio was tested, and that was so. We didn't make any pre-treatments.
Because there are many acidic compounds, I think maybe not necessary to make pre-treatment. Already there are many, you know, the acid, so it's very good to get maybe large surface area. Okay, thank you very much. I think you have better measure the surface area, very important for, you know, cleaning waste and other contents, contaminants, pollutants. So thank you very much. And please, I think the second speech is Mr. Safa, Biochar physical properties and effects on the soil. That is prepared by our team. Mr. Safa will present instead of our team on behalf of our group. So Mr. Safa, please try to summarize your speech and be punctual. You have only 15 minutes. And after end of session, we will try to get all questions, I think, totally together. Please.
Okay, thank you, sir. Can you show the slide?
I think you can add your slides.
Okay.
Can we make share screen?
Thank you, dear presidents. since I have a problem with my shoulder.
Mr. Mustafa, if you have problem, we will try to, screen screen. If you couldn't do,
Okay.
we will do it.
Just a minute, please. Okay.
Actually, I stopped the screen share.
Okay, already
So
we have
it
screen.
was because of me, maybe.
Okay, sorry.
Okay.
Yeah, good. Please continue. You can maybe, make bigger. Oh, okay, now better. Please go ahead.
Thank you, dear President. My name is Sefa. I am working at the University Department of the Biosystems Engineer. My experts area are soil tillage, sowing machinery, and crop production. In addition to these subjects, we have recently been conducting some research to improve soil quality criteria. We are planning to work on the subject that can be a solution to the salinity and unproductivity in soil of the other province, especially together with the dear President, Professor Dr. Alma, and we think that Biochar can be an alternative solution to such problems. Today, I will try to give you information about the physical properties of the biochar and effect on the soil. As you know, biomass, which is an important alternative energy source today, can be obtained from the different sources. This resource can be listed as agriculture, production waste, sewage waste, solid municipal waste, animal waste, industrial waste, and forestry waste. Biomass is collected from its source and stored in a suitable place. Then it can be converted into the biochar, bio-oil, and syngas after various thermochemical process. A schematic view of this transformation process is given in the figure. In the thermochemical conversion of biomass process, such as carbonization, gasification, pyrolysis, hydrothermal carbonization, and torrefaction are used. Each of these processes has different operation parameters. Biochar is a product with high carbon content, which is formed as a result of combustion of the biomass in an oxygen-free or low oxygen conditions. Biochar contains between 60 and 80% carbon. As seen in the diagram, we can classify the physical properties of biochar as its structure, particle size distribution, surface area, and finally porosity. The structure of the biomass varies according to lignin, hemicellulose, and cellulose ratio. These structures may change according to some operating parameters used in the thermochemical conversion process. The most important of these operating parameters: pyrolysis tip temperature, heating rate, pressure, holding time. As stated in the previous slide, the structure of the biomass consists of cellulose and hemicellulose and lignin. If the biomass has a high lignin content, the yield of the biochar increases. The increase in the amount of the cellulose reduces the biochar yield and increase the syngas yield. In addition, hemicellulose degrades between 250 degrees to 300 degrees. In cellulose and lignin, these values range from 190 degrees to 900 degrees. On the slide, you can see the change in the structural feature of the biomass depending on the temperature. The structure of biomass deteriorates in 4 stages depending on the temperature. When the temperature is below 200 degrees, no change is observed in the structure of the biomass. At this stage, the extractive biomass components are degraded. When the temperature is between 200 and 300 degrees, the hemicellulose structure begins to deteriorate. When the temperature approaches to 600 degrees, maximum degradation occurs in the cellulose and more stable ligand structure. At the temperature above the 600 degrees, all of the non-carbon atoms are removed and carbon content in the biochar increases. Another physical properties of the biomass is its particle size. Particle size of biochar varies according to the feedstock, pyrolysis system, and process conditions. The particle size of biochar varies depending on the feedstock. For example, biochar obtained from the feedstock such as wood has a large particle size than a stable feedstock. The method used in the production phase is another parameter that affects of biochar particle size. Generally, fast pyrolysis method causes lower particle size than the slow pyrolysis. The operation parameters used in the production phase can also affect the particle size of the biochar. In the studies, it has been stated that the pressure increase also increases the particle size of the biochar. In summary, in terms of the improving soil physical properties, the best particle size of biochar can be obtained from the feedstock, which has low ligand content. Also, the fast pyrolysis or gasification process, high temperature and low pressure conditions are more suitable for production of the small biochar particle size. Another physical properties of the biochar is its surface area and porosity. The porous structure of the biochar affects its adsorption properties. The pores in the biochar can be examined in the three parts: macropores, mesopores, and micropores. Pores with a diameter greater than 50 nanometers are called macropores. Macropores provide aeration and hydraulic permeability of the soil and provide a living environment for the organism in the soil. Pores in the range of 2 nanometers to 50 nanometers are called mesopores. Mesopores allow the soil to absorb the liquid. Pores smaller than 2 nanometers are called micropores. Thanks to micropores, the surface area of the biochar increases and its absorption capacity improves. Due to its high carbon content and porous structure, biochar can be used as a soil coordinator, especially in unproductive soil in arid climatic region. Biochar can be positively changed to bulk density, porosity, penetration resistance, hydraulic conductivity, aggregation level, and plant weather content of the soil. Soil bulk density is defined as the weight of the unit volume of the soil. In other words, it is an indicator of soil compaction. The weight of 1 cubic centimeter of soil suitable for agriculture production is 1.3 grams. We think when this value increases 2 grams, there is a decrease in plant production. As the soil bulk density increases, its porosity, infiltration rate, moisture content, and plant root development decrease. When biochar is mixed into the soil, a decrease in soil bulk density occurs. The reason for this is that biochar has a porous structure and thus reduced soil compaction. On the slide, you can see a study that examined the effect of biochar on soil bulk density. In the study carried out under the laboratory condition, increases the biochar amount into the soil causes decrease the soil bulk density. Another study conducted under the laboratory condition, rice husk was used as a feedstock. In this study, the biochar was produced at the 600 degrees pyrolysis temperatures. As a result of mixing the biochar into the soil, a decrease in soil bulk density has occurred. Another study carried out under field conditions, the sawdust was used as a feedstock. In the experiment, the pyrolysis temperature was 400 degrees. As a result of mixing the biochar into the soil, decrease in soil bulk density was determined. Similarly, another study conducted under the field condition, waste straw was used as feedstock. According to the result, increasing the biochar rate in the soil bulk density decreased. Similar results were obtained in another study conducted under greenhouse condition, where waste straw was used as a feedstock. In another field experiment, corn stubble was used as a feedstock. Biochar was produced at a pyrolysis temperature of 400 degrees. When the obtained biochar was mixed to soil, a decrease in soil bulk density was observed. Aggregate stability of the soil is an indicator of the resistance of the soil aggregate to mechanical effects. Due to its porous structure, biochar allows the formation of a stronger structure by entering between the soil aggregates. Therefore, biochar improves the aggregate stability of the soil. We see the result of the research carried out to examine the effect of biochar on the aggregate stability of the soil. As can be seen, it has been determined that biochar increases the aggregate stability of the soil in all of the study. Soil hydraulic conductivity is an indicator of the rate of transmission of water to soil substrates. In soils where biochar is at, the hydraulic conductivity value decreases. Due to porous structure of biochar, water molecules are retained in the topsoil. As can be seen in the picture, the hydraulic conductivity value decreases when the biochar produces at pyrolysis temperatures of about 350 degrees is mixed into the soil. You can see the result of two different studies on the slide. In both slides, the addition of biochar to the soil decreases the soil hydraulic conductivity. When biochar is at the soil, the water holding capacity of plant increases. This is because biochar reduces the infiltration rate and retain water in the topsoil. On the slide, you can see a pyrolysis study using wood as a feedstock. According to the result, the amount of water available in the plant increased when the biochar was mixed into the soil. Similar results were obtained in the other study examining the effect of biochar on plant water content. As you can see, the increase in the amount of biochar in both studies increased the amount of water available in the plant. Biochar affects soil temperature due to its dark color. The dark color of biochar also changes the color of the soil and affects the amount of reflection of the sun's rays. Soil which biochar is at have lower reflectivity than other soils. As a result of this feature, evaporation decreases and moisture content increase. In addition, in some studies, it was observed that while the soil temperature increased at night in soil with biochar addition, the soil temperature decreased during night. Summary, when a biochar is at the soil bulk density and hydraulic conductivity decrease. In addition, soil porosity, aggregate stability, and moisture content of plants increase. Also, the pyrolysis temperature changes the physical properties of the biochar produces and indirectly change its effect on the soil. Biochar produced at high temperatures retain more moisture than produced at low temperatures. And also biochar produced at high temperature has large pore area than the low temperatures. These pore structures hold more water and transmit more water to the plant body. As the amount of the biochar applied to the soil increases, more improvement in the soil physical properties is observed at the research. And finally, mixing the biochar with organic fertilizer into the soil, the physical properties of the soil developed better.
Okay,
Hope we can reopen our unproductive agriculture area to production by applying biochar, especially in the province. I hope we are able to meet at the conference we will organize face-to-face after the pandemic process. Thank you for your patience.
Yeah, thank you very much, Mr. Sefa. Actually, it was very good summary from the literature. I hope you will try to do your best to do your own experiment. I know you have pyrolysis system we both together, and in the future we will try to in the Igdir region, especially there are many the salty soil, and others you do some DAF area. So we will try to do our best to on our system. As we know, there are many effects, positive effects of biochar on the soil properties. I hope after forest fire in Turkey recently, unfortunately, it was very actually non-sense and not good the condition position. Actually, we are very sad for this. We may use this, the burn some forest trees use as a biochar in the to treat and to to highlight the properties of soil properties. So thank you very much. If there is any question, quickly we can get one question. Otherwise, we will continue with our presentation. Thank you very much, Mr. Sefa.
Thank you, sir. Thank you, sir.
Please wait a moment if there is any quick and important question. Otherwise, we will try to do our end of session. I think there is no question from my side, from my the screen. Okay, thank you very much. For the next presentation, should belong to also bio-oil separation and upgrading techniques. I will try to present this one. Let me share the screen. Okay, thank you very much. You were more quickly than me. Yes, this one, our title is bio-oil separation and upgrading techniques, pyrolytic oil study for many people, but there are many actually, the handicaps of the pyrolytic oil like pH and other things. We will try to solve this problem with our site. Actually, the population, second slide, please. Okay, thank you very much. And population growth.
Professor, I'm sorry for interrupting you, but now then you can control your slide by yourself also.
Okay.
This is your option now. Thank you.
Yeah, population growth going very quickly. And first slide. I think slide going very quickly. There is something wrong on the screen. I cannot go back. Can you arrange one more? Okay, biomass, I think, can you go back? I couldn't move to go back for the first slide. Okay, population growth going very quickly and energy demand also very high recently because population is going to be 9 billion people. And the natural gas is our main sources. Coal, oil is, traditional source of energy and other forest fuels. And bio oil, this one. And 100 million barrels per day for bio oil is available in our section. Okay. And biomass has two kinds of conversion. One is the thermochemical conversion, another is biochemical conversion. So we can get biofuel. Biomass is as in dry and grinding and use a reactor. There are many types of reactors. I will do quickly design and cyclone to collect this charge for inorganic materials. And bio-oil is our main target. And also we can, summarize biochemical conversion by anaerobic digestion, which is known biogas, is much available in Turkey recently for a municipal, especially institution is doing this one. And biochemical conversion using fermentation to get bioethanol is going to increase recently, not as much as we desire, but there are many companies to try, like Pankobilik in Konya, try to get from the waste of sugarcane. And another thermochemical conversion, as we know, is very usual terms, so-called pyrolysis. The solid fuel, liquid fuel, gas could be obtained from the pyrolysis system, and hydrothermal, which is, told by Mr. Jem, just for waste meal of the olive, and combustion, classical way of burning, and gasification system is main chart and way of the biomass bio-oil. And bio-oil classified wood and municipal waste, agricultural waste, and forestry. Recently, municipal solid waste and industrial solid waste, also in like Turkish EPDK, Energy Ministry institution, department, and plus this one, industrial waste also could be considered as a bio-oil. That is new idea for enlarging the sources of biomass. So biomass contain different, the cellulose, hemicellulose, and lignin, different ratios for corn meal and maize straw and sugarcane rice waste, and between the 45 for cellulose and to 21 for lignin, is changing. So every biomass has their own features. We will try to get a system according to properties. And production, also reactor and cyclone and drying system and grinding, because particle size is very important for the first stage. And also we can get gas, and gas could be recycled to heat the system. Reactor is a more efficient exergy system for biomass energy. And there are many reactors types: fluidized bed, circulating fluidized bed, fixed bed, ablative reactor, auger, and vacuum reactor. Recently in our laboratory, we use circulating fluidized and fixed by using azote, the nitrogen. And this on system of, in our laboratory already we have the pyrolysis system, very efficient, and many students doing master and PhD degree on this, the system. And hydrothermal liquefaction is very important system. Also, we can use some water and some catalyst, and temperature between 250 and 400 degrees centigrade, and pressure is not more than 20 megapascal. Also, we could get many products: aqueous phase, gas products, bio-crude oil, and solid residue, different kind of things, as well as pyrolysis. We could use hydrothermal liquefaction, and very efficient and not so dangerous system for security of the system. Actually, our main topic is the properties of bio-oil. As we told, moisture content is high. As you can see, the bio-oil is 10–30% moisture, but crude is 0.1 is very high. And oxygen ratio 28–60, but crude oil is less than 1.0. And OH divided per carbon ratio 0.9, 1.5. And another one is 1.5, 2 is hydrogen higher than our products. Viscosity is also, of course, compared to crude oil is 100 centipoise, but compared to gasoline and biodiesel, maybe is 200 times higher than gasoline viscosity, main handicap of design. So moisture content and oxygen content and hydrogen, less hydrogen content and low, the hydrogen HH value, the calorific value and viscosity is a many handicap of the bio oil. So in this study, we will try to upgrade this oil by using different separation and upgrading methods. Co-design literature study is not our own study. Please try to move the slide. I think there is something on the screen. Okay, now. Okay. And moisture content of boiled oil is when many handicap of the system. Also, as we thought, and lower the calorific value and lowers the flame temperature and lower the viscosity is a very important point for our study. So we will, please, next slide. I think there is something wrong on the screen. Could you help me to move? I couldn't control, okay. There is something wrong on the screen maybe. And oxygen content also handicap of our system, moisture content in the bio-oil and oxygen content and lowers the calorific value, also unstable in storage and transportation. And bio-oil also contain 45% oxygenated components. These many, the main handicap and negative point of the design. Also polar properties, is very important because of oxygen and we couldn't mix them with oil. So that is also should be upgraded. Maybe I have many slides and couldn't move. Okay. Density of bio-oil is very high. Petroleum is lower than bio-oil. These are also important and difficult to inject the machine. Okay, please let me go. Viscosity of bio-oil also very high. So we have to decrease by using some solvent, and viscosity could be affected by time, moisture content, temperature, feedstock type, and collection procedure and processing stages. That's very important point. We have to decrease this, the viscosity by using different techniques. We are, arranging the properties of moving slowly. And pH scale, when we are going to consider pH scale, acidic and neutral and alkaline stages, organic acidic properties is very high. That make corrosion on the machine and other parts of the system. So we have to decrease this, increase the pH by using several methods. So moisture content, viscosity, and pH is very important parameters of bio-oil. They should be upgraded by different way of thinking. Yes, please. Okay, thank you. Ash content also is high compared to bio-oil and gasoline, especially potassium and sodium is important point. We have to clarify and try to make the pure combustion and erosion and metal wear, etc. is very important. Bio-oil aging instability, thermal decomposition of biomass and rapid quenching and vapors, also reactive components, instability, and aldehydes, carboxylic acid, alcohols, phenols, and unsaturated hydrocarbons is try to make unstable this one. If you are going to stay maybe 1 or 2 minutes, within 1 or 2 minutes and 10 minutes, you can get very thick and thick coffee-like composition and oil. So that is also a handicap of our system. And bio-oil prepares problems and causes, and as we arrange high viscosity, high moisture content, low calorific value, acidity, and low H2 carbon ratio, and weak distillation, and non-miscible with the hydrocarbon fuel aging and solid coal. These are main negative points. We don't have good time to explain everything. And next one. And so how to clarify and then upgrade this oil? We have two methods. One is separation, another one is upgrading. One is separation. It's very important to remove the acetic and formic acid must be, removed from the system. And distillation process also is very important. Pyrolysis, bio-oil, distillation, and distillate. You can see the color actually is dark, but we are going to use the ozone treatment at 1 degree Celsius by using some methanol. I tried many times. We could get very open color and light color. I mean the oil. That's very important. Like look like gasoline system. This one important. I mean the system. Yes, comparison distilled bio-oil and gasoline properties. You can get upgrade. For example, raw bio-oil moisture is 8.20. Gasoline less than 0.1. Fraction distillation also moisture 2.70. You can get from 0.60 kinematic viscosity, and values energy value is 40. But vacuum distillation also you can 45. So from the 38 you can increase to 40, almost close to gasoline, like after the distillation of system. Yes, molecular distillation is very important method recently used. Less heating time, high efficiency, low operating temperature is the more, the economic and the positive side of the system. You can get two fraction is light fraction and heavy fraction. A molecular distillation you can get after the molecular distillation, get the oil, this fraction, this kind of, the component like olefin and aromatic O-cresol, phenol-cresol, look like gasoline, and others make catalytic cracking by using zeolite. You can get more light, the component, and the residual fraction containing water, sugar, and lignin parts. And sugar could be used for alcohol by using fermentation system that is open side of fraction. This is very important point for molecular distillation. Upgrading of bio-oil also important. As we explained, we have two fraction, light fraction, middle fraction, and heavy fraction. And light can be used as esterification, catalytic cracking, and steam reforming to get hydrogen system. I use this system in USA in NREL for 1 year. It's very interesting. Hydrogen, the more 20% of the hydrogen could be obtained from biomass. And also for heavy fraction, we can get emulsification to homogenize, the miscible properties of bio-oil. Yes, solvent extraction also use water, chloroform, ethyl acetate. Ethyl acetate is very important for getting the lignin part, water for getting the sugar part to making bioethanol, chloroform for getting, a non-polar system, alcohol and phenolic system is very important solvent. We are using this. And column chromatography, there is mobile phase and stationary phase, and you can get fraction, his one, and a very light fraction like gasoline could be used, and we can use many element, hexane, toluene, benzene, pentane, ethyl acetate, and methanol. Methanol is very good solution already in gasoline. We are using 20% of methanol in gasoline. Is very good solvent for bioethanol. Yes, bio-oil upgrading, I have to be quickly because time is going up. Bio-oil upgrading, chemical, physical, and others, physical filtration, solvent addition, emulsification, chemical esterification. We can use some alcohol to make esterification by carbonic acid, catalytic cracking by zeolite, and hydrooxygenation is very important to remove oxygen, which is make heavier density around 1.5, 1.2, but diesel is 0.9, so we have to decrease density to make light fraction, and other steam reforming and supercritical fluids. Filtration, hot steam filtration. In this stage, we are using filters and also pyrolysis and other fraction types, and bio-oil and the gas could be used in the next system. Let's go ahead. The hot steam filtration, in this filter, very important. We can use some metal filter or some ceramic filter or some sinter ceramic filter. Of course, very expensive, but very efficient system. Temperature should be more than 200 degrees centigrade to get around 250 is better to get hot filtration and clarify and highlight our bio-oil. And steam filtration, we can go ahead, not necessary to explain too much. Yes, solvent additives, very important to decrease the, the viscosity and properties of the bio-oil. to get the combination and integrate with biodiesel or diesel or gasoline. And additional alcohol is very important, especially as we told, the problem of the bio-oil is high viscosity and the instability. Instability could be obtained by isopropyl alcohol. We put this one in our lab, and alcohol is very good phase separation, and then try to homogenize and decrease the viscosity. Solvent addition, there are many types of solvent addition, and homogeneity will increase the lower heating value, and by oil and reduction in viscosity. This one also we can pass, I have already told. Emulsification, very good and easy, economic, and very simple upgrade method. You can see the phase differentiation could be removed by using emulsifying agent. This agent, we can see now Twin 16 and lignin could be used for, yes, this one Twins 85 to span 60, and lignin can be used for as emulsifier. In the food, also industry could be used this emulsifier, very effective, and to make homogenize bio-oil, because there is phase differentiation and different types of level. And acidification can be used some alcohol with carboxylic acid, and we can follow this type and get acidified bio-oil, which is low viscosity and high calorific value and more homogenized, the fuel. I have to finish acidification. Please go ahead and pass this one again. Catalytic cracking, actually in Turkey, we have a lot of zeolite. We can use zeolite to crack into many different, the types, deoxygenation, cyclization, oligomerization, aromatization, isomerization, alkylation, polymerization system. Mechanism could be done by catalytic zeolite. 250 degrees centigrade and under 45 megapascal pressure, we could use, very nice and very light oil from the bio-oil by using catalytic cracking system. Is very convenient and very popular system in developed country to use bio-oil for getting fuel. Yeah, we can pass this one. It's not necessary to enter detail. And also we can pass, there are different kind of catalytic like silicium, potassium carbonate, etc. Please, natural, and also we have some, the artificial zeolites. Of course, diamond also very good for this. Hydro deoxygenation, we can use hydrogen to make oxygen carbon catonization and aldol condensation, esterification. Our aim to make dehydration by using hydrogen to remove the OH hydroxy group from system and to decrease the density of the oil. Okay, please, next one. And yeah, this one also same material. Steam conversion also. We can use steam, H2O, water. Temperature is around 350 degrees centigrade by syngas. Syngas and water could react and produce hydrogen. So hydrogen, they increase the value because calorific value hydrogen is 122, gasoline is 60 megajoule per kilogram, and wood is 20 megajoule per kilogram. So hydrogen 122, this one. So increase the calorific value of this system, and then get light and low acidic properties by oil. And also then we can pass. Because in the hydrogen, we can use some catalysts. Supercritical fluids, very famous. Actually, I studied this one in Japan with Professor Saka. And also we have patent on the Saka diesel, use the supercritical point. Hydrothermal system, usually they subcritical point, but for water, we use 275 degrees centigrade and 350 megapascal to crack, the biomass by using the water or methanol under high pressure within 4 minutes. And we can get very high efficient methanol base, and methanol mix bio-oil is very important, novel and innovative diesel for recent times. In Japan, many companies are starting using this oil. Supercritical fluids, we can pass this one because we have no time to minimize bio-oil applications. Of course, we can use many purposes for heat, for electricity, for engine, for chemistry. Actually, in USA, I tried to use bio-oil ethyl acetate fraction to make phenol formaldehyde polymer to use industrial, and then the brake cleaning system. We can use like polymer is my main study to use this one for this purpose. Of course, for gas turbine boiler and for chemical industry, for food flavors, for aromatics, because you know in the banana there is some component which is available in the wood also, and olefin, resins, adhesives is very important in Georgia. One company using bio-oil-based adhesive at the moment, and agrochemicals and fertilizers. And thank you very much for listening. I want to close my the speech because I prolong. I am sorry because I am chairman. I have to be an example. And thank you very much. Yes, if there is any quick question, I can get it. Otherwise, at the end of the session, we'll discuss together. If not, please, Mr. Cemil Cem Kantarlı, İsmail Cem Kantarlı. Again, I think you have another speech, which is so-called utilization of the soft drink industry waste as energy feedstock. Mr. Cemil.
Yes, I'm here.
Sorry, I extend and takes your time.
No, it's okay. Thank you so much. Thank you for the nice presentation. Let me share my screen again.
Not share, I think the organizer.
No, I have share. Can you see the screen now?
I think you can enlarge. I think may select one.
Yes, I have started. This time I will talk about the utilization of soft drink industry waste as energy feedstock, specifically the breed tea waste. Here's the outline of my study. As you know, human beings will face the depletion of fossil fuel resources in the near future, and due to the fossil fuel dependent energy consumption, global warming has been unavoidable, and therefore sustainable clean energy sources must be produced and used more extensively than ever before. And one of these sources is biomass energy or bioenergy, which is produced from chemical energy stored in biomass. And biomass refers to all kinds of wastes, such as agricultural crops and residues, animal residues, municipal solid waste, sewage sludge, animal residues, and industrial residues. And the main components is carbohydrate compounds. And using conversion technologies, either biochemical conversion or thermochemical or thermochemical conversion, they can be used as energy feedstock. By biochemical energy conversion, lignocellulosic biomass can be converted into methane, hydrogen, or bioalcohols, but this conversion technology suffers from the disadvantage such as long operation time, reproducibility, sensitivity against pH, and etc. And also, besides these disadvantages, lignin can be a problem since it resists biological degradation, and in some cases it creates biomass conversion. So with the advantages of short process time and high availability of all types of biomass, the research focus has turned towards thermochemical conversion processes. Of course, there are some challenges in thermochemical conversions. The disadvantages of using biomass in combustion and gasification systems are low rentability of this biomass, low energy density, high tar formation during the processes, and heterogeneity of the biomass can be a problem. So as an alternative, biochar can be utilized instead of biomass. So the treatments of biomass result in the production of biochar. Biochar is a stable carbon-rich product obtained from the thermochemical conversion of plant and animal-based biomass in an oxygen-free limited environment, as I mentioned in the previous presentation. The superiority of biochar to biomass is the lower amount of volatile organic compounds. It includes almost no water, can be stored for many years without decay, and it has higher energy density than biomass. You can obtain biochar by either, depending on the moisture content of your biomass. If the biomass is dried, you can apply torrefaction. If it's wet biomass, like green tea waste or two-phase aluminum waste, you can use hydrothermal carbonization. And hydrothermal carbonization involves the application of heat and pressure to biomass in an aqueous medium, and it avoids the drying step for biomass. You don't need to dry the biomass. It's an advantage, and it converts the wet biomass into biochar, specifically named as Hydrochar. By applying pressure and medium temperature range, you can obtain Hydrochar, which is a stable carbon aqueous solid product. It has a lower oxygen to carbon ratio compared to the original biomass by the removal of oxygen. For hydrothermal carbonization, the composition of biomass is dominated by reaction mechanisms like dehydration, decarboxylation, aromatization, and recondensation, as happens in torrefaction, with dry carbonization. But different from dry carbonization, the composition of biomass during hydrothermal carbonization is initiated by hydrolysis, which exhibits a lower activation energy than most of the hydrolytic decomposition reaction. And in this study, I focused on the use of green tea waste. It is given in the literature that fermented black tea is a very popular hot drink in Turkey. It has an annual per capita consumption of approximately 3.2 kilograms in Turkey yearly, and after the brewing of fermented black tea, green tea waste remains as a waste with high water content. And this waste is also produced as a waste of soft beverage, soft drink industry during the production of iced tea, or it is also produced as a waste of local coffee shops, local tea houses. So green tea waste can be classified both as domestic waste and beverage industry, soft drink industry waste. Utilization of this waste is possible by, again, converting into an energy densified product, hydrochar, like carbonization. Being a wet waste, it can be converted to hydrochar by hydrothermal carbonization in the temperature, medium temperature range.
And no study exists about hydrothermal carbonization of brick waste in the literature. And in the study, utilization of brick waste as energy feedstock was aimed, and the fuel and combustion characteristics of dried hydrochar was investigated. Also, slugging and falling bits of obtained hydrochars were calculated in order to foresee potential ash-related problems during their combustion. The brick waste was delivered from a local coffee shop. It had a solid content of 13% approximately. When dried, its high rating value on dry basis was pretty high, and on dry basis it had a high calcium oxide content. And when we look at the experimental conditions, this time we used a different reactor, a smaller reactor with a capacity of 100 milliliters. And in a typical experiment, we mixed 5 grams of waste with 37.5 grams water, which corresponds to the original water content of the brick waste as received. Actually, I dried the brick waste before starting the experiments. I mixed the dry brick waste with water. At this ratio, the duration time of 60 minutes was chosen for the experiments, depending on the preliminary studies, and reaction temperatures were chosen as 220 to 280 degrees Celsius, and the heating rate of 5 degrees Celsius per minute was applied. And at the end of each experiment, the reactor content filtrated and aqueous phase was separated, and the hydrochar obtained was dried at 105 degrees Celsius for 24 hours, after washing with 100 grams distilled water, and the standards approximate and elemental analysis was realized, was carried out. Also, combustion properties of the obtained hydrochars was determined according to the thermobarometric analysis carried out under oxygen atmosphere, and ash composition was detected by ICP. When we look at the results, first we look at the char yields, and hydrochar yields decreased sharply with the increase of temperature due to the enhanced degradation of brick waste as the temperature gets higher. The mass yield of hydrochar obtained at 260 degrees Celsius was found to be lower than that of biochar obtained by pyrolysis carried out at 200 degrees Celsius, possibly due to the decreased stability of biomass components under supercritical water conditions. Approximate and elemental analysis of hydrochars reveals that ash contents of hydrochars were higher than that of brick waste. This was attributed to the existence of most of the inorganics, mainly calcium salts of brick waste in less soluble form in water, less water soluble form. Therefore, only different from the two-phase polymeal waste, only 25 to 35% of ash in brick waste could be dissolved in subcritical water during carbonization. and the relative content of hydrocharge decreased and its fixed carbon content increased with increasing process temperature. When we look at fuel characteristics, we observed that in parallel with the increase in carbon content and decrease in oxygen content, high relative values, calorific values of hydrocharge have increased. And energy yields of hydrocharge decreased due to the decrease in mass yield, even despite the increase in heating value, it's increasing temperatures. The decrease in mass yield was very much, so the energy yields decreased. And when we compared the energy yield of biochar obtained at 260 degrees Celsius as a product of torrefaction, was higher than that of hydrocharge obtained at the same temperature due to the higher mass yield of biochar. And when we look at the one prevalent diagrams of hydrocharge, during hydrothermal carbonization, we can say that biomass degradation at low temperatures occurs by both decarboxylation and dehydration reactions, while at elevated temperatures, mainly the carboxylation reactions occurs since the hydrogen to carbon atom value doesn't change much. Seems to be only the carboxylation occurs at higher temperatures. And as a result of the process, lignite coal-like hydrocharge is obtained at lower temperatures, while hydrocharge at elevated temperatures had lower oxygen to carbon ratio due to the decarboxylation reactions than lignite coal. And when we look at the combustion characteristics, we observe that ignition temperatures of hydrocharge are slightly higher than that of original feedstock, and ignition temperatures of hydrocharge obtained at higher temperatures and all hydrocharge had higher ignition temperature than reactive waste, but these values are still lower than that of lignite given in literature, which depicts the risk of self-ignition, and burnout temperature of all hydrocharges were found to be lower than that of reactive waste and lignite. Low temperature hydrocharge had higher average reactivity than high temperature hydrocharge. And finally, when we look at mineral composition of reactive waste and hydrocharge, turned by, I thought that it was ICP, but it was actually CRF. And main components of reactive waste seems to be, when we look at calcium oxides and potassium oxides. And at the end of hydrothermal carbonization, potassium oxide seems to be removed due to its solubility in water, but calcium oxide content increases due to its dissolubility. And alkali index values of hydrocharge were observed to be lower than 270 implying that their combustion would be safe as expected due to the removal of potassium oxides, oxides, and acid-base ratios of hydrocharge much higher than 1, and slagging index values higher than 2 imply a high to severe risk of slagging during combustion. On the other hand, the following index values of hydrocharge are much lower than that of TÜBA WCEST, decreased from 30 to 1.3. And this implies a decrease in the falling potential by heat process from high to actually medium risk. And in conclusion, I can say that this process, hydrothermal carbonization, eliminated some of the disadvantages of TÜBA WCEST as well by converting to hydrocharge with higher calorific value and lower falling potential, but it was insufficient in lowering the ash content and slag potential of feedstock. And I would like to thank my friend Özlem for thermoeconometric analysis of TÜBA WCEST hydrocharge and biochars. Thank you for listening and thank you for your patience.
Thank you very much, Mr. Ismail. Actually, it was very good experimental, good effort have you done, and congratulations.
Thank
and
you.
Next speech is impact of using, thank you very much, using ethanol gasoline compound fuel on performance of a dual fuel vehicle. I don't know who will present. Parmida Kamariye, Porya Ahmedi, Nader Javani, and Mehrar Raisi. Nusara Simbati, Parmida Kamari. Who will present? Ramada, Ms. Ramada, please go ahead.
Okay.
You have 15 minutes. I am sorry to extend time. Please try to be punctual, as short as possible. Thank you very much. Go ahead.
Okay.
Welcome. Sorry. Yes. Please try to share screen. Okay. Good. I think you can start from first slide.
Yeah.
Can you make a slide screen is more better?
Yeah.
Okay.
Okay. Okay. Hi everyone. Okay. Hi everyone. Welcome again to Conference of Energy Science and Technology. Let me briefly introduce myself. My name is Parmida Kamari, and I am a student of Tehran University. I am delighted to be here today to talk to you about my project. My study is about ethanol gasoline compound fuel and its impact on performance and pollution of dual fuel vehicles. I should appreciate Dr. Ahmadi for his support and his favor, and Dr. Javani for his assist and his accompany, and Dr. Raisi for his help too. So let's go to main points. Okay, first we have introduction. We talk about environment and its issues. Then we talk about our study goals and our passion for this subject. After that, we have vehicle specification and properties of different fuel compounds. Then we talk about modeling and software that were used. At the end, we check the results and discuss about that. Okay, we know that environment is very important nowadays. We should keep it clean and save it for our next generation. But some factors make it polluted, like transportation, which has the most effect. Using fossil fuel produce greenhouse gases emission, which leads to global warming. we should consider alternatives for this fuel and issue. Then we have two solutions for this problem. At first, we should find and use new technology like electrical vehicles, fuel cell ones, or hybrid and hybrid plug-in cars. And second, that is a study based on is new fuel like bioethanol or ethanol gasoline compounds. So we study on ethanol gasoline by 10% ethanol and 90% gasoline, or better to say E10. And we compare gasoline, E10, and E100, and an electric car that that's Nissan Leaf we choose. So now we examine our vehicle specification for gasoline, E10, and E100. For them, we use EF7 engine, and we choose Samand as our case of study, which we can see in specification. The left table is the specification of our engine, and the white one is our car details. So for electric vehicle, we choose Nissan Leaf. It is popular and it is one of the most sold cars. The car and the battery properties are as follows, you can see. Okay. Here we use three different fuels, gasoline, E10, and E100. As you can see, adding ethanol increased density, latent heat, and octane number of fuel. On the other hand, it decreased LHV or low heating value and air to fuel ratio that leads to more fuel consumption. Okay. In this part, we talk about modeling the project. We use two software, AMSIM and Grid. AMSIM is a software for dynamic simulation, and Grid used for life cycle assessment. By AMSIM, we model EF7 engine, and the car select driving cycle and calculate fuel consumption by motor map. By Grid, we estimated pollutants like CO2 and greenhouse gases, also calculate life cycle energy. We talk about them in next slide. Okay, here we have the AMSIM model of engine and car. In figure A, we have model of engine, and we gather the data of engine like spark and fuel injection. But in figure B, we have the model of car like weight, engine, and we got the map of engine too. So in this slide, we talk about driving cycle used for modeling. WLTC, or Worldwide Harmonized Light Duty Vehicles Test Cycles, which is a global driving cycle. It consists of 4 parts, low, medium, high, and extra high. It can simulate urban, suburban, rural, and highway by an almost equal between urban and non-urban paths. By this driving cycle, we can calculate mean fuel consumption, CO2 emission, and pollutants like SOx used by passenger cars and light commercial vehicles. Okay, by previous works, now we can calculate fuel consumption, and then we can see how much energy they use. As you see, adding more ethanol increase fuel consumption and energy use. As it's obvious, EV has the less energy use, and it can be a good choice. So here, PM 2.5 are particle polluted air and very dangerous for people's health and reduce visibility and in some cases it causes air appear hazy. But for PM10 are very small particles that found in dust and smoke. As it's clear, as we add ethanol to gasoline, more PM 2.5 and PM10 are produced. In this case, gasoline is the better option and using weak compounds of ethanol gasoline. Okay, now let's check CO and SOx. CO forms when carbon fuels burn incomplete, and SOx is because of sulfur in fuel. We can see that EVs has the most SOx and ethanol increased SOx, but in CO engine, EVs has the least amount and adding ethanol doesn't change CO amount notable. In this slide, we talk about greenhouse effect, that gases like carbon and carbon dioxide and methane, they're responsible for greenhouse effects. We can see that ethanol decrease greenhouse gases and EVs are the best alternative for us. Okay. In conclusion, electric vehicles use 30% less energy than an internal combustion engine. And they produce only 0.02 kilogram per 100 kilometers, which is 10 times lesser than gasoline and 9 times lesser than ethane. EV release 12 kilogram per 100 kilometer greenhouse gases, which is 40% and 75 less than gasoline and ethane. Then ethanol can improve power and efficiency, but in some cases, like SOx and PM10, increase pollutants. Pure ethanol increased PM 2.5 and PM10, 4 times more than gasoline, which produce almost 0.006 kilogram per 100 kilometer and 0.0008 kilogram per 100 kilometer respectively. And at the end, lack of technology and not being easy to use and touchable are the reason of using modern technologies like EVs less than it should be. But following the recent advances, it is going to be widely used in new future. Thanks for your consideration and thanks for keeping up with me.
Thank you very much for your presentation. I think I have some technical problem. Another speech is sugarcane leaves and tops for biogas production by batch experiments. I think Professor Nusara Simbuatun will present. Could you start? Thank you. Please, we can start as soon as quickly because we have no time. Please go ahead.
Yes. Can you hear me, Professor?
Yes, quite good. And welcome. And please start. Let's start. Thank you very much.
12 minutes only. Okay.
I hope to see all of you in Turkey by face to face after pandemic. Thank you very much. Please start. Let's start.
Okay. Good afternoon from Bangkok, Thailand. My name is Nusra Sinbuatong from Kasetsat University. I come from Bangkok, Thailand. Hello, Chairman. Thank you very much to chair this session. I would like to present our research work in the topic of sugarcane leaf and top for biogas production.
I'm sorry, try to make 15 or less than 15 minutes because we extend time, and try to summarize and go your data, not so introduction section. Thank you very much. Sorry to interrupt you. Please.
Yes. My topic is sugarcane leaf and top for biogas production by batch experiment. Thailand is the second world exporter of sugar. Sugarcane production has resulted in increased quantities of byproducts. Sugarcane byproducts are basically of two types. One is leaf and top, and the other is bagasse, which is fibrous residue after the juice is extracted. The figures show Thailand's sugarcane production and sugar factory. Renewable energy is crucial for creating economic opportunity and protecting the environment. A farmer of a sugarcane crop intends to earn extra income from leaf and top. Sugarcane leaf and top are often burned prior to harvesting and cause emission of air pollutant, that is PM10. Hence, we study to change agricultural waste to renewable energy source. In this case, sugarcane leaf and top was studied to produce biogas. In our country, we can see the still the sugarcane from another type. Sugarcane cultivation in Thailand is mainly located in the and northern region of the country as anaerobic digestion is the bioreaction process for biogas production. Agricultural waste to renewable energy. The bioreaction consists of hydrolysis, acidogenesis, acetal, and methanogenesis. Finally, we got methane. The objective of this study were to investigate the potential of sugarcane leaf and top as a source for biogas production by using sugarcane leaf and top as substrate for co-digesting with cow manure by batch experiment, and to compare the digestion and the co-digestion. To compare the digestion of a slurry of sugarcane leaf and top with the co-digestion of a mixture of sugarcane leaf and top and cow manure, and to investigate the system performance in terms of biogas production and organic conversion efficiency. The percentage of methane and methane you will report. Also, the organic substrate degradation efficiency will report. Substrate was sugarcane leaf and top. In this case, substrate is feedstock, and I can call it substrate. Core substrate is cow manure, and bacterial starter was luminal microorganism from cow. Methodology: 50 milliliters syringe were used as an aerobic batch reactor. The substrate slurry of sugarcane leaf and top at 20% of solid content were prepared for digestion, and the mixed substrate slurry for sugarcane leaf and top to cow manure to water at the ratio of 10 to 10 to 80 was prepared for co-digestion. The initial substrate was analyzed for pH and the organic substrate, that is COD, TS, TVS. COD is chemical oxygen demand, TS is total solid, and TVS is total volatile solid. Bacterial starter from cow lumen was measured in terms of MLVSS, or mixed liquid volatile suspended solid. The bioreaction occurred when the biogas produced until the biogas stopped. It took 57 days. The produced biogas in syringe was recorded, and the biogas was sampling to determine the percentage of methane. The digested slurry was analyzed for final pH, COD, and TVS. We got the organic degradation efficiency in terms of percentage of COD and TVS degradation, and finally we got the methane yield. These are the 50 milliliter syringe which were used as an aerobic batch reactor. The pen tip of the syringe was sealed with the silicone glue. When the biogas produced, the puncture will draw back. The total gas will be recorded and was sampling at this point to determine the percentage of methane.
Please try to be quickly because we have 4 minutes. Another session we start. I am sorry. You can do as much as summary as possible. Sorry. Please go quickly. Thank you.
50 milliliter were used as an aerobic batch reactor. The bacterial starter of 4 milliliter was added in all 10 syringes. The mixed substrate series of sugarcane leaf and top at this low ratio was for digestion, and at this ratio was for co-digestion. The last 2 syringes were prepared as bank. Bank was prepared by add only bacterial starter and water. Here is the real picture. The total gas was recorded by reading the scan at the side of the syringe, and gas was sampling for methane analysis.
You can go the result. Result is better. I good. Yeah.
Characteristics of the sugarcane leaf and top are as shown. Characteristics of the carbonate are as shown. Characteristics of the substrate solution for digestion and co-digestion are as shown. Biogas. Here we show the total gas and methane produced for digestion, and another slide show the total gas and methane for co-digestion. For digestion, the percentage of methane was 31.8, and for co-digestion, the methane was 37%. Organic degradation. Here we show the organic degradation efficiency of digestion and co-digestion in terms of COD and TVS. Methane yield. Methane yield is used as the indicator of the reactor performance. Co-digestion of sugarcane leaf and top with carbonate gave greater methane yield than the digestion of sugarcane leaf and top alone. We summarize all the data as shown. The percentage of methane content was quite low, and these are methane yield. The methane yield obtained from the co-digestion was 145 per gram COD degraded, while that of the digestion was 61. However, the methane yield obtained from this study was still far from the theoretical methane yield, which is 350. So further study should improve to enhance the methane production.
Thank you very much for your nice presentation, and try to make the last sentence summary. And it was very nice.
Sugarcane leaf and top could be a source of energy to produce biogas. Yes. Co-digestion of sugarcane leaf and top with cow manure gave greater methane yield than the digestion of sugarcane leaf and top alone. Batch experiments still gave the raw methane content and methane yield. Enhancement of methane production should be further studied by changing the reactor configuration and type of operation, and preheating the sugarcane leaf and top prior to co-digestion in order to make them appropriate for bacterial reaction.
Yeah, thank you very much.
For your kind attention.
Yeah, thank you very much, and see you another occasion, and have a nice day, and thank you very much for nice presentation. Goodbye, and see you again. Thank you very much. I am sorry to make quickly because we have a next session starting 15 Turkish time. So because of pandemic, we have to follow the, the artificial system. I hope welcome to Turkey, and then see you and study together and make collaboration. And thank you very much on the behalf of Turkish Academy of Science, and have a nice day. Have a nice study and thank you very much. And see you again and try to join next occasion, I hope. And goodbye.
Goodbye.
Good afternoon. I think it is time we can start the next session. Welcome all. By the way, I am Borat Murkutuk from Niğde Meral İstemir University Mechanical Engineering Department. I am going to lead this session, General Session 2, on fuel cell and batteries. Our first presentation is PD modified polyrhodanine for methanol electrooxidation reaction, which will be presented by Professor Ramazan Solmaz, but unfortunately he is a little bit ill, so we have to skip this presentation and continue with the next one. The second presentation is selection and synthesis of ceramic electrolytes for intermediate temperature solid oxide fuel cells. Our presenter will be Handan Özlu Torun. Please, lady, you have the floor. Can share your screen and start presentation. Thank you.
Hello, hi everyone. My name is Pandan. Welcome to my presentation. Excuse me. I work at Kahramanmaraş İstiklal University. Today I will talk about selection of ceramic electrolytes for intermediate temperature solid oxide fuel cell.
Sorry for interrupting, but you can switch to full screen mode, please.
Okay. Technical.
You can use F5, just F5.
Okay.
You can push F5, I think. Okay, anyway, we can continue in this form. Doesn't matter.
Okay, okay. Okay. Okay. First, I will explain fuel cell. Then I will talk about solid oxide fuel cell and ceramic electrolyte. After that, I will explain ceramic electrolyte synthesis and characterization. Finally, I will explain results. The fuel cell converts the energy of the fuel cell directly into electrical energy by means of an electrical reaction. Many different fuel oxidizer combinations are possible. For example, the hydrogen cell uses hydrogen as fuel and oxygen as oxidizer. The natural gas and alcohol can be used among other fuels. Fuel cells can be used in many applications, such as in main load power plants, in electrical and hybrid vehicles, as backup power, as an off-grid power supply, on laptop computers, as a portable charging station of small electronic device. Fuel cells can be generally categorized into 5 types according to electrode types used. Electrolytes provide the movement of different ions in each. These types: alkaline fuel cell, molten carbon fuel cell, phosphoric acid fuel cell, proton exchange membrane fuel cell, and salt oxide fuel cell. Salt oxide fuel cell, the structure of single cell, anodes, electrolyte, and cathode. The choice of ceramic electrolytes affects operation temperature and efficiency of the Sofc system. Operation temperatures are very high. Sofc is also used to multi-cogeneration units. Oxygen ion thermal is preferred as the ceramic electrolyte. The ceramic electrolytes must have the properties such as poor porosity, good density, good oxygen ion conductivity. Most used ceramic electrolytes, these: bismuth oxide, the coefficient of thermal expansion is very high. This causes cell breakage. Zinc oxide, the operation temperature is high. It increases the cost of applicability. Lanthangalate, it is an expensive compound. It increases cost. Cerium oxide can be used at low temperatures. However, it can be used in improving its ionic conductivity. It is a good ceramic electrolyte for Sofc. Cerium oxide fluors structured ceramic electrolyte. Different types of compounds are doped at different rates to increase the oxygen ionic conductivity of cerium oxide type electrolytes. Single and multi-stable addition can be made into the cerium oxide. In this study, the properties of different cerium oxide compounds were investigated. The compounds were synthesized by Soljet method. For synthesis, after waiting, the starting compounds were taken into a breaker and solved in distillated water. Then citric acid and ethylene glycol were added to it. A yellow-brown gel alternated by heating between 80 to 90 Celsius without mixing. The resulting gel pre-dried and 110 Celsius. It was sintered 800 Celsius for 20 hours. XRD, CM, and impedance spectroscopy were used in the characterization of all samples. Initially, the crystal structures of the powders was determined. According to XRD evaluation, all samples have cubic polar structures. According to table, the lattice parameter change with doping. The change in cell parameters is due to the radii of doping ions. The scanning electron microscopy gives information about the microstructure when the images are examined. In the synthetic temperatures of the pellets was not sufficient at 2000 Celsius. Grain size is not homogeneous in the structures were formed depending on steric temperatures. Impedance spectroscopy is an important technique used in the conductivity measurement of ceramic electrolyte. According to curve information, as the measurement temperatures increases, the grain resistance decreases and the grain boundary resistance remains. Although the conductivity increases with doping, it is still not sufficient for Sofc application. Conclusion: in this study, cerium oxide ceramic electrolyte synthesis, which can be used at low temperatures, was carried out. The following results were found. Single-phase samples were alternated by doping. selected peptides positively affected conductivity. By increasing the synthetic temperatures, more regular grain formation can be achieved. Forests can be destroyed. However, the synthetic temperatures should be increased. Structural improvements are required for the obtained compounds to be used to practice. Thank you for your attention.
Thank you very much for the nice presentation. Let me check whether we have any question. I think there is no question. So thank you again. Good luck with your studies.
Thanks, Chairman.
Okay, we can continue with the next one, which will be on energy performance of SOFC integrated SCO2 microgas turbine. I think it is going to be presented by Uğur Akbulut, but I can't see him on the panelist list. So just skip this one and continue with the next one. If he is back, then we can continue with this one as well. So the fourth presentation is highly stable pouch cell scale quasi-solid state lithium air batteries. And it is going to be presented by Mustafa Çelik, I think. We have Mustafa Çelik. Yes, I can see him in the panelist list. So, Handan Hocam, can you stop sharing your screen, please? Okay, thank you very much. So you have the floor, Mustafa Çelik. Please go ahead. We can't hear you, by the way. Okay, please unmute your microphone as well.
Okay, you can see me?
Yes, we can see you, your presentation, and we can hear you. Please go ahead.
Hello, my name is Mustafa Çelik. I am a PhD student at the Material Science Department in Sakarya University. My research area is gel polymer electrolyte, apply for lithium-ion battery. Today I'm going to present some of my work. Sorry. Okay, in this presentation, I give a brief introduction about lithium-ion battery system. Okay. In this presentation, I give brief about the lithium-air battery system and present the challenges and issues to lithium-air battery system. And then I focus the issues on electrolyte, particularly polymer electrolyte. Then I discuss the experimental design on the production of gel polymer electrolyte, and it is composite. And then I present of my research result, which is included the electrochemical measurement of gel polymer electrolyte in the presence of different ceramic electrolyte, such as aluminum oxide, titanium, and LASPE. Okay, the batteries are important in our daily life, charging our electrochemical devices and electrochemical electrical cars. So far, lithium-ion battery have been widely used. However, particular applications are limited due to low energy density of lithium-ion. Therefore, the development of a new energy system is required. Recently, lithium-ion batteries have been received much attention due to the high theoretical specific capacity, which is 10 times higher than the energy density of certain lithium-ion batteries. Sorry. A typical lithium-ion cell is composed an anode, which is lithium metal, an electrolyte and cathode. Based on electrolyte tips, lithium-ion cell designed for model, including aprotic, aqueous, and hybrid solid state. The focus of our research is on solid state electrolytes. due to safety concern, which is the solid electrolyte cannot catch on fire. It's flexible and cannot evaporate. Electrolytes, three types, solid, liquid, and composite. The solid electrolytes are classified the polymer, ceramic, and composite. The common polymer electrolytes, PO, PVDF, PMMA, and ceramic such as LATP, LLTO, and composite, it is a mixture of the polymer and ceramics. The advantage of polymer electrolytes, low weight and flexibility and good interface adhesion in comparison of ceramic electrolytes, have high thermal and electrochemical stability and good ionic conductivity. In our research, we use pouch cell for lithium-air battery system, and the flexibility is important factor. Therefore, polymer electrolyte was used. But there are so many challenges is using polymer electrolytes, such as low ionic conductivity and low mechanical properties. Okay, to solve polymer electrolyte issues, some technique have been suggested. First technique is development of new polymer by mixture different polymers, for example, PO, PMMA mixing. And the other technique is cross-linking polymer electrolytes, such as PVDF, HFP. And then next technique is addition of ceramic, addition of chemicals, including lithium salt, improve the ionic conductivity and mechanical properties, such as lithium hexafluorophosphate and lithium perchloride. Also, adding ceramic can be another solution, such as titanium dioxide, aluminum oxide, and LATP. The most common technique is adding lithium salt. Have been used are lithium perchloride, LiTFCI, lithium hexafluorophosphate. Each one of them show the unique properties. For instance, lithium hexafluorophosphate has large ion size and high dissociation energy, and LiTFCI show high electrochemical stability and unique structure, by unique structure, LiTFCI. And lithium hexafluorophosphate indicate high solubility and low cost. And then the other technique is adding ceramic particle. By addition of the ceramic, a composite polymer electrolyte obtained. By composite polymer electrolyte enhance mechanical stability, show better thermal stability and low crystallinity. In our previous work, we have used different lithium salts, including lithium perchloride, LiTFCI, and lithium hexafluorophosphate with different concentration. Among them, 1.5 LiTFCI has shown the best performance in lithium air cell. Now, in our work, we have mixed various ceramic with PVDF HFP polymer at different weight percentage. Here, aluminum oxide, titanium, and LATP was used at weight percentage of 2.5, 5, 10, and 20. For preparation of composite gel polymer electrolyte, the ceramic particles are dispersed in acetone with ultrasonication. Then their obtained was added PVDF HFP polymer and liquid electrolyte mixture by stirring was added for 6 hours. The obtained gel polymer electrolyte was caused on a glass by Dr. Blade. Okay. The morphology of composite gel polymer electrolyte doped by aluminum oxide various weight percentage was observed using FESM image. As you can see from FESM image, by increasing weight percentage of aluminum oxide, and agglomeration has increased due to filling the space between polymers reduction porosity. The best result was obtained adding 2.5 weight percentage, which show the highest porosity of structure, which is beneficial for battery performance. XRD result show the increasing aluminum oxide, decreasing the crystallinity and low crystallinity indicate a battery performance in a battery system. The morphology of gel polymer electrolyte by titanium dioxide was evaluated as well. From FESM image, you can see the increasing titanium dioxide 5% weight percentage start to increase porosity, and after increasing 10 weight percentage higher porosity and observed, when titanium dioxide with a weight percentage increased 20 weight percentage, porosity decreased and caused agglomeration. Adding LATPE in gel polymer electrolyte with weight percentage, the highest porosity we can see 5 weight percentage in LATPE. Electrochemical result, as I modified the ionic conductivity is an important factor for gel polymer electrolyte. Electrochemical impedance spectroscopy was performed to estimate the ionic conductivity value for different composite gel polymer electrolyte. And the result showed the highest ionic conductivity to LATPE at 5% LATPE in polymer electrolyte, gel polymer electrolyte. To calculate the lithium transfer number, the chronon parametry test was carried out, and result showed by increasing weight percentage of ceramic, the lithium transfer number is increased, and the highest lithium transfer number was for aluminum oxide 20 weight percentage. And then to observe the window voltage range at composite gel polymer electrolyte, linear sweep voltammetry was performed, and the LATPE with 5% weight shows the highest voltage range up to 7 volt. Electrochemical performance of composite gel polymer electrolyte was investigated by galvanostatic charge and discharge test. The lithium air cell was charged and discharged for 10 hours. The highest over potential was observed LATPE with 5%, then TO2 titanium dioxide 5% weight. The cyclability of the best result for gel polymer electrolyte was performed, the LATPE 5 weight percentage gel permactose show the highest cyclability up to 20 cycles. It is good in lithium air cell. Okay, in this video, you can see the lithium air cell assembling. This is an anode lithium and gel polymer electrolyte, 5% adding LATPE in PVDF-HFP polymer matrix. It is assembling to cell and then working the cell by connecting to a fan in glow box, and then open atmosphere. It is the lithium air cell working on open atmosphere, open air atmosphere. And then my purpose of lithium air patch cell, custom patch cell. This is video. No. Okay. This is the pouch cell scale, custom pouch cell, lithium air cell. Then we can fabricate a pouch cell, and you can see in this video the prepared cell is working after connecting a fan in the air atmosphere. Thank you for listening.
Thank you very much, Mustafa Çelik, for the informative and timely presentation. It's a good work. Let me check whether we have any question. There is no question. Okay, thank you very much again.
Thank you for listening.
We can pass to the next one, but I think we have Uğur Akbulut now, so we can listen to him, I think. The topic is on energy performance of SOFC integrated as CO2 microgas turbine. So Uğur Akbulut, please share your screen and start your presentation. You have 15 minutes, including the question parts. Uğur, are you there?
Can you hear me?
Yes, we can hear you and we can see you.
Excuse me for not opening first. I'm trying to, I will share, if I press through. I couldn't manage to share it.
Can you see the share screen button at the bottom of the Zoom window? It is in
okay,
green.
I try. I'm seeing. Okay. Can you see my screen now?
Yes.
Okay.
Please switch to full screen mode by pushing F5.
Okay. F5. No.
Okay, you can.
F5 not work. Okay, I will continue like this or.
Okay, no problem. Please go ahead.
Because F5 not work with this. Okay, thank you. Okay. Okay, I will take I will be faster and I will be efficient time. Thank you very much for listening, everybody. Welcome. So today I will be talking on energy performance of solid oxide fuel cell integrated supercritical carbon dioxide microgas turbine system. I will talk about motivation. This is my outline: motivation, objective, perceptions, analysis, results and discussions, and conclusions. Supercritical carbon dioxide cycles have benefits such as higher efficiency comparing to traditional system. These traditional systems cycles such Brighton cycles, steam Brighton, and Rankine cycles. What is the advantages? The advantage of this supercritical cycle is to have a small physical footprint about environment with a simple layout, compact turbo machinery. This means our turbo machinery will be smaller. We will have a bigger amount of power with smaller turbo machinery, and the heat exchanges will be smaller. These benefits will support the goal of sustainability, is to improving environmental impact of our planet by supporting people and generating a profit. The main objective of this study is to investigate the effect of the effect of operating temperature on the energetic performance of solid oxide fuel cell integrated supercritical carbon dioxide microgas turbine with intercooling system. Our system has a simple layout. There are three main parts: green hydrogen supply system, solid oxide fuel system, and micro gas turbine system. If we look at our schematic system layout, this is our schematic power system. For example, there is two cycles. First cycle is solid oxide. First cycle is supercritical carbon dioxide cycle. Here a tank, gas tank, and we have two compressors compressing it. Here, recuperator one is a kind of a heater and gain heat from outside of the microgas turbine. So we make a heat gain here to efficient system. And after that, it's going after this gas goes after respectively three recuperators: recuperator 2, recuperator 3, recuperator 4. These recuperators are at the end of the solid oxide fuel cell. As you know, there is a high temperature for solid oxide fuel cells. It can be around 800 Celsius, 1000 Celsius. So we are gaining heat from these recuperators. We are gaining heat from air channel, hydrogen channel, water steam channel, and the supercritical carbon dioxide comes to the point of microgas turbine inlet temperature. These temperatures mostly around 500, 600 Celsius. So this is a cycle. We can say a bottom cycle. The other cycle is the cycle of solid oxide fuel cell work cycle. We have renewable hydrogen, air. Renewable hydrogen should be preheated and air should be preheated. We use recuperator number 5 and recuperator number 6 to get some heat regeneration from the exhaust channel of the solid oxide fuel cell. So this is a total system, a total efficiency system for the power generation, you can say. When we come to analysis and modeling, we have assumptions. Carbon dioxide is assumed to be idle gas, but its compressibility factor is considered for the calculations. Hydrogen is idle gas. Supercritical carbon dioxide with interconnect and renewable hydrogen, fat planar soak are used in the system, as I said. And the other things are, for example, during the calculations, a residential area includes 100 apartments that each one consumes 24 kilowatt per day is considered. Outlet pressure of supercritical carbon dioxide is 9.2 megapascal, which should be higher than the critical pressure. This is important. In the whole cycle of supercritical carbon dioxide, we have to be above critical pressure for carbon dioxide. This is the 7.39 megapascal as in electrician knows. Inlet temperature of main compressor is considered to be 32 Celsius. That should be again higher than the critical temperature, 31.1. These are, I think, very important. The actual form of we can say the isentropic processes takes place at the gas turbine and the compressor. This means we use the efficiency of isentropic efficiency numbers. So we have input parameters for the solid oxide fuel cell. These are well-known parameters from literature. Solid oxide fuel cell operating temperature between 800 and 1000 Celsius. We use operating pressure as air atmosphere. We have current density 0.4 and etc. You can see the other calculation parameter. For example, cell active area is important, 550 centimeter square meter carre is the power to generate the enough power, and number of cell stack is 100, etc. In table 2, we have input parameters for the solid oxide, supercritical carbon dioxide Brighton cycle. So I talked about the compressor inlet temperature, 32 Celsius, and compressor inlet pressure, 9.11 megapascal. Also, important thing is turbine inlet temperature and turbine outlet pressures, inlet pressures. We taken them 500, 600, 700, etc. Celsius, etc. And micro gas turbine inlet pressure 20 megapascal and outlet pressure is 9.2 megapascal. We taken the efficiency of micro gas turbine 85%. Also efficiency for heat exchangers 90%. So now we can pass the calculation of solid oxide fuel stack power. For a unit cell area, each cell produces work equals the current density times net cell voltage, thus produce solid oxide fuel cell stack power. As we can see, equation 1 here is this is soak power, and for one this is number of cell times stack, and we have net cell voltage here, you see. So we can easily calculate the soak power with this equation. For the heat generation of soak stack, assuming the air is composed of only oxygen and nitrogen gases, the heat generated from soak stack can be calculated as this formula. Here, where Q soak donates the heat generation of soak stack, and here the molecules, molar numbers of gases, hydrogen, oxygen, etc. I am again saying that the use we think oxygen and nitrogen gases is the air. So this formula, these are the enthalpies of these gases, etc. Here we can calculate heat generation. We put the power of soak here at the end of the formula as W soak. So The other important thing about these calculations, we have to calculate the outside temperatures and or pressures of compressors. Temperature is very important, as you see. In this equation 3, we can calculate the outside temperature, exit temperature of compressor. Here you see the important thing, you have to use compressibility here, Z, and the polytropic number N is very important to use. You see in equation 4, we can calculate the exit temperature of turbine. Here again, this is the same idea. So, in accordance with the first law of the thermodynamics, in equations 5, we can calculate compressor work. And again, we can calculate turbine work. We use compressor efficiency and turbine efficiencies here, and the mass flow of the supercritical carbon dioxide and enthalpy differences. About the capacity of coolers are like heat exchangers here. We have mainly 2 coolers. If we take one cooler, this is cooler heat capacity. This is cooler efficiency and enthalpy difference. We can multiply this with the mass flow of the supercritical carbon dioxide and easily obtain the result. Efficiency of supercritical carbon dioxide Brighton cycle and overall system efficiency. As you know, we have to define efficiency for every system personally. Every system has its spatial efficiency. Here we have the parameters: work turbine, Q cooler. We have 2 coolers. But one of the cooler is between 2 compressors to give effectiveness to the compressors, and the second cooler is to cool the supercritical carbon dioxide to the tank temperature 32 Celsius, and this shows we have 2 compressors actually, and this is the Q-Sofc. Q-Sofc means this second cycle, I mean Brighton cycle, takes heat from the solid oxide fuel cell. So this is the system efficiency in same mentality. Let's come to the result and discussions. So this is small or okay. Figure 3 illustrates the variations of Sofc efficiency, Brighton cycle, and total system efficiency. Here you see, according to efficiency as a function of Sofc operating temperature under the various inlet temperatures, turbine inlet temperatures. According to figure 1, Sofc efficiency increases from 28.4% to 49.8% with the rise of Sofc operating temperature from 800 to 1000 Celsius. If we take a constant Sofc operating temperature, Brighton cycle efficiency and total system efficiency increase with the rise of microgas turbine inlet temperature from 500 Celsius to 700 Celsius. So we obtain the characteristics of the efficiencies here. Here, another result. Figure 4 shows the variations of Brighton cycle efficiency and total system efficiency as a function of Sofc efficiency. Considering the exceptions of this study and figure 3, it can be said that Sofc efficiency changes with only Sofc operating temperature. Sofc efficiency fuel cell efficiency changes with only solid oxide cells operating temperature, and the Brighton cycle efficiency is only influenced by the gas turbine inlet temperature. For this reason, in figure 4, Brighton cycle efficiency is seen stable with the increasing of soft efficiency, and normally at a constant soft efficiency value, Brighton cycle efficiency increased from 19% to 24.5%. With the rising microgas turbine inlet temperature from 500 to 700 Celsius. On the other hand, system efficiency is influenced by both operating system, soft operating temperature and microgas turbine inlet temperature. From figure 4, it is seen that system efficiency increased from 39.5 to 58% with the rise of soft efficiency. And at a constant soft efficiency system, efficiency increase with the rise of Brighton cycle efficiency. These are the characteristics of system. Conclusions. It can be said that soft efficiency changes with only soft operating temperature, and the Brighton cycle efficiency is only influenced by the microgas turbine inlet temperature by. On the other hand, system efficiency is influenced by the both soft operating temperature and gas turbine inlet temperature. At a constant soft operating temperature, Brighton cycle efficiency and total system efficiency increase with the rise of gas turbine inlet temperature. System efficiency increased from 39.5 to 58% with the rise of soft efficiency, and at a constant soft efficiency, system efficiency increased with the rise of Brighton cycle efficiency. So I am finishing my talking. Thank you for listening to me.
Thank you very much, Mr. Akbulut, for the nice presentation. You have a very good result, especially you improved the efficiency very well by adding SOFC. We have two short questions. The first one is, how did they determine the values of SCO2 for the analysis?
Okay, we use NIST. NIEST in internet.
Mm-hmm.
I didn't realize that long name, but you can find easily it, and I can give the long name.
Okay, no problem.
Mm-hmm.
The second question is, what is the compression rate of the compressors?
I will check again from the assumptions. If I didn't write it, I will talk about that. Compression rates. Okay, compressor ratios is 1.5. 1.5. I wish to add something about this. Normally, for compressor pressure ratio, it changes such these systems between by 1.5 to nearly 2, but not much. And turbine rise ratios, these are around 2 or 1.8. So we use two compressors and divide the pressure ratios. If you multiply the pressure ratios, 1.5 to 1.5, this is 2.25, I remember. So this is the turbine ratio. I wish to add this for the question.
Okay, thank you very much. And another one, what is the fuel type in the SOFC?
Okay.
I want to know the fuel type, yes.
So we made a parametric study. So we used as fuel hydrogen, we use hydrogen and we use air. But this is the parametrical. And we didn't make an experimental work, if they ask this.
Okay, thank you very much again.
No problem.
Mm-hmm. Okay, we can continue with the next presentation. Then it is hydrogen fuel cell bus performance assessment with machine learning degradation prediction. It is going to be presented by Pouri Ahmadi, but I think it is going to be a video presentation, if I am not mistaken. So is there anyone from TÜBA to share this video? Because he lives in Los Angeles, so yes, that is the video. I think there is a problem with the sound of the video. I can't hear anything.
I will start with introduction. I will go to life cycle assessment. And the most important part is fuel cell degradation prediction using machine learning. And I will follow by some results and discussion. And I will close this one with some concluding remarks. So, okay, so this is why I can say that energy is global, meaning that if you look at CO2, global CO2 emission, transportation accounts for about 23% of the total global CO2 emission. If I just, magnify transportation, what will happen here? This is the transportation. 73.9 accounts for ground transportation, and so 46% of that accounts for buses and heavy-duty vehicles. So this is why we want to talk about transportation sectors here in this study. So when it comes to transportation and when it comes to sustainable development, for a specific case of the transportation, we need to look at fuel. So fuel in transportation should have these four major items. It should be safe, secure, healthy, and durable. Look at this one, right side. We have gasoline versus diesel. We have CNG versus LNG. We have LPG versus biofuel. We have hydrogen, and we have electric vehicles. The question here is, which way I need to go to reduce the emission and to approach sustainable development? So this is the major item, and we need to look at that one. Which way we go, this one, or this way, or this way. But here, when it comes to transit buses in British Columbia, Canada, let's see what will happen. If I use diesel fuel in British Columbia, Canada, I have emission around 1,500 grams of CO2 per kilometer. If I use hydrogen, which comes from coal, I still can reduce emission, but this is still a lot, which is around 1,200 grams CO2 per kilometer. If I use compressed hydrogen, comes from natural gas, I can, cut emission almost half of that one compared to diesel emission here, and the emission is 780 grams per kilometer. If I use plug-in hybrid electric vehicle, the emission is 580, and if I use compressed hydrogen from electricity, I can say that the emission can be almost 70% drop from the diesel case. But the nice thing is, if I use compressed hydrogen coming from nuclear and the waste is from thermochemical water splitting cycle, then emission will be less than 100 grams per kilometer. Like every devices that we have, performance of fuel cell is strongly affected by the electrochemical reaction within the compartments in the fuel cell. And fuel cell gradually degrades with time. And most reasons for fuel cell degradations are load cycling, freezing and thaw, humidity and temperature change, radical scavenger attacks, and mechanical stress and corrosion. Okay? So what does that mean? It means that if this is a voltage, for a single cell, and over the time here, the voltage will drop. The question is how much this voltage drop is. And the question here can be really affecting the performance of fuel cell. It can be connected to the life cycle assessment. And when we want to say that we are trying to deploy hydrogen buses or hydrogen vehicles, what will happen? Since we do not have sufficient vehicles on the road operating based on hydrogen, and we do not have this voltage loss. So the question here is how to use these voltage loss and integrate it into the life cycle assessment framework. Okay, this is the one of the experiments that we did at Simon Fraser's University, Vancouver. So we have two types of degradation. One is mechanical degradation, mainly due to acceleration, deceleration, humidity difference, and chemical degradation is majorly affected by radical attacks. So you will see that this is the pinhole preparation starting, and this is the chemical degradation attacks. So this is done by scanning electron microscopic at 4D lab, Simon Fraser's University, where I did those type of experiments. Study data collections. City of Victoria was selected as a case study in British Columbia, Canada. The capital city of Canadian province of British Columbia on the southern tip of Vancouver Island of Canadians Pacific coast, and the total area is 215 kilometers square, and the total population is 335,000 people are living there. So the roadmap was selected from the southern part in the downtown Vancouver all the way to University of Victoria over there that you can see this stuff there. And so the most important part is for the simulation and modeling, we need to use vehicle velocity to get the data from those ones. And we got these data, and just we render some data in order to be able to use that in the simulation part. So these are some information about transit buses in Canada. I will just move on. The most important part for us is hydrogen part that we have, but this data is for 2009. I will discuss when we have the update of those numbers. So this is the fuel cell specification. We have the fuel cell specification for buses. You can see the fuel cell power and maximum power, and you can see these are the hydrogen tanks over there. So let's move on. Okay, modeling framework. I told you that most of the life cycle assessment so far, they didn't consider the fuel cell degradation. If we do not consider fuel cell degradation, we ended up with not realistic data about their emission reduction. In this study, we use experimental data from the fuel cell research lab, and we use different machine learning techniques, because what happened over there, we had about 1,000 hour data, and we want to project for example, 18,000 hour for an operation of city buses. We use different machine learning techniques, and at the end, we got the voltage losses. Then we use semiconductor enzyme software where environmental properties can be included as an input, vehicle speed and specification like vehicle front area and the number of people, getting into the bus and driving cycle and control strategies. When I have this one, I will use this software. I can calculate fuel consumption, and voltage drop can be also calculated. And I use the life cycle assessment method. Then I can compare all of those results. This is the screenshot of the enzyme software. What we did over there, we use this machine learning techniques to get the voltage losses and implement it into fuel cell ECU part, and you can see all other parts of the simulation. Okay, so this is the data that we have. We had this much, about around 1,500 hours of experimental data in the lab. The question here is how to predict these ones. So based on those data and using different machine learning techniques, and the major one was LSTM, long short-term memory machine learning, we would be able to project this voltage drop up to 6,000, and we can just extend that data. You will see that. So these different machine learning techniques have a really good agreement with experimental data. So the projection was really good for us to do the job. And once we got this voltage drop, what happened? We used that semiconductor OMDIM software in order to be able to calculate this total energy required for this boss. So what is this one? This is the fuel cell without degradation, means fresh fuel cell or beginning of the life of this fuel cell. But if fuel cell operates for 20,000 hours, what will happen? We have this much increment in total energy. And this one is the base comparison for the diesel buses. And at the same time, looking at the effect of fuel cell and degradation effects on the fuel cell consumption, we will see that if fuel cell operates for 25,000 hours, we have around 21% increment in fuel consumption, which I will now show you how that can be affecting the emission, the life cycle emission of this vehicle. So this is so far we calculated it. We found the fuel consumption, and let's see life cycle assessment. Life cycle assessment is a technique that is used to evaluate environmental and economic impacts of a product or process in their lifetime. The left side we have fuel cycle. On the right side, we have vehicle cycle. So we have different part of this in life cycle assessment. So, okay, using this life cycle assessment, at the same time, you use grid software and GHGenius software, and we calculate all of these emissions and air pollution emissions for fuel cell and pure diesel. So the results show that in most of the cases, fuel cell has low air pollution, except particle matter. Why? Because in this case, we consider steam methane reforming as a hydrogen production source, and vehicle production has some sort of more particle matter emission compared to diesel as a base. So in this case, if fuel cell is considered without degradation, we have this amount of emission, while if the fuel cell degradation, which is in a real problem, we need to consider fuel cell degradation. What will happen? 12% increment in emission will occur. So this is why fuel cell degradation should be also considered in the assessment, design, and analysis and deployment of any type of hydrogen or electric vehicles. Similarly, if you use fuel cell with degradation, it is the real case with degradation I will call that. If I use this one here, at the end, I can get 51% emission reduction in British Columbia, Canada, based on the real data. So, okay, so far we concluded that using hydrogen fuel cell buses can significantly reduce the diverse effect of diesel fuel buses. The question here is, what about the cost? So, in order to have a bias cases, because one is with higher cost, the other is the other one, which is diesel with higher emission. In order to compare those two ones, what we did here, we consider penalty cost of air quality cost and greenhouse gas emission cost. If you look at this one, the cost associated with emission is equal to the emission gram per kilometer multiplied by emission cost of a pollutant. So we have air quality ones, we have greenhouse gas emission ones. For more details, you can read this paper where all of these numbers were obtained. Okay, again, using this life cycle assessment and do the economic assessment, we will see that these are the emission damage associated with all the emission, either air quality one or the greenhouse gas emission. And okay, the interesting one is, okay, what about the total life cycle cost? So these are the data from 2009, where the purchase cost where the purchase cost for fuel cell was around $2 million, very high in 2009. So if we do the economic assessment, we will see that the total cost of the hydrogen fuel cell bus is also triple or 4 times higher than total cost of diesel. But what will happen if in 2016 the cost of the fuel cell, the purchase cost of, dropped, and it was around $1 million. Calculating and assuming and using this fuel cost for the life cycle and maintenance cost and all of those ones, and we could, drop the total life cycle cost of the fuel and hydrogen buses. But what will happen there? But the important thing is, if portion of different parts in total life cycle, if we can produce 400 buses per year, what will happen? The cost of fuel cell, the life cycle cost of fuel cell and diesel can be also similar. But in this case, hydrogen one is still higher than diesel one. But next slide nicely present, if we can have more than 400 buses, the total life cycle cost of fuel cell is dominated, and the fuel cell cost will be lower.
Okay, thank you very much from the staff of TÜBA. Since he is not here, we couldn't take any question. So we can continue with the last presentation. Investigating the environmental effects of a hybrid UAV with fuel cell according to the 2 different scenarios. The presenter is Duran Çalışır. So please, sir, the chair is yours.
Yes, sir. Hello, everyone. My name is Duran Çalışır. I'm working at Eskişehir Technical University in 1994. Now, currently, I am working, continuing the PhD program at Eskişehir Technical University. Dear Chairman and dear participants, we share my presentation. Is it okay?
Yes, but you can switch to full screen mode. It is better to switch to full screen mode.
Okay. Okay?
Okay, it is okay now. Please go ahead.
Okay. Now we can exit full cell. Now. Sorry, sir.
It's okay, no problem.
Is it okay?
Okay.
Okay. Dear Chairman and dear participants, I will make a presentation about a hybrid UAV with fuel cell investigating environmental effects according to 2 different scenarios. My presentation plan is consist of 5 main titles. These are, okay, introduction, description of study, analysis, results, and discussion and conclusions. Okay. Sir. Share them. In recent years, abnormal environmental events.
Sorry for interrupting, but we can see now your second slide only now.
Okay. Okay.
Okay, now introduction.
Now, okay?
It's okay.
In recent years, abnormal events have been observed frequently in our country and in the world. Against the increasing environmental problems, more environmentally friendly and energy efficient products and preferred. With the developing technology, unmanned aerial vehicles, that is UAV, are used in many areas. In this study, the environmental effects of a fixed wing UAV with a proton exchange membrane, PEM fuel cell, and a hybrid power group on agricultural lands, the sea were investigated. The life cycle assessment method was used to reveal environmental impacts within the scope of the study. Scientific researchers on the use of PEM fuel cell in UAV were examined. The PEM hydrogen fuel cell UAV used in the study is introduced. Two different scenarios has been defined for this UAV. The PEM hydrogen fuel cell used in the study introduced according to the calculated environmental effect. As a result of study, the environmental effects agricultural lands were higher than the effects on the sea. Wait a minute, sir. And now, introduction. Within the scope of study, scientific research on PEM fuel cell UAV were examined. PEM fuel cell have started to be used frequently for increased flight time in UAV, approximately now 2 flight hours increased. In this direction, optimum power consumption in fuel cell is modeled by Bradley et al. In 1929. In Dudek et al. And Özbek et al. Studies proton exchange membrane, hydrogen PEM, hydrogen fuel cell were used to create the hybrid power pack. The energy production function of fuel cell DMFC that use methanol fuel directly with the another type of fuel cell were investigated by Gonzalez et al. In 2019. In recent years, research has been done on one new type of fuel cell that use ammonia as fuel. It was made Lepenia et al. About fuel cell producing energy from hydrogen provided by hydrolysis of sodium borhydrure. Especially in mini UAVs, there are studies indicated that aerostate shaped hydrogen fueled PEM fuel cells outperform lithium ion nickel NiMH batteries researched. Sorry. Aerostate shaped PEM fuel cell is benefit, especially in the response of polymer lithium polymer batteries under dynamic loads, provided the interrupted energy. The life cycle assessment studies on hydrogen and alternative fuel used in fuel cell were made by Biochar and Dincher 2070. There is a gap that environmental impact caused by of the use PEM fuel cell in UAVs. Within this study, it's aimed to contribute to this gap. Now, description of the study phase. In this study, a fixed wing mini UAVs was used, and its name is Hydra. Hydra was designed by Eskişehir Technical University Anatolia design team. Hydra can take off and will by launch and no landing gear. Therefore, it can be land on the fuselage. The body wings made of extended polystyrene foam. The tail set is made of balsa wood. Some of main characteristic is of Hydra UAVs. This table wingspan 2.8 meter, length 1.6 meter, stall speed 10 meter per second, cruise speed 16 meter per second, maximum flight time 6 hours, landing gear, no landing gear, throw from the end landing body, maximum takeoff weight 6.5 kilograms. The energy source of the UAV has been hybrid system. The main power unit consists of 1,300 watt electrical motor. This is 7-cell lithium polymer battery and propeller. Aerostat shaped 250 watts hydrogen PEM fuel cell was added this unit. Power unit and hybrid power system was performed. It consists of PEM fuel cell, hydrogen tank regulator. Used method this study is life cycle assessment. Scenario 1 hour flight over the agricultural lands in the Eskişehir Sarıcakaya Valley. Scenario 2 1 flight hours on a sea coast at an altitude of 300 meters at a distance 100 meters from the seashore to the sea. Assumptions: there is no wind. Air temperature is on average 15 Celsius degrees. Analysis: in LCA application, the CIMA Pro 9.1 software was used. The analysis is based on Ecomovement 2.6 database. Calculation made according to the CML-IA baseline and recipe methods. 10 impact categories has been selected for a CML-IA baseline method. 3 impact categories has been selected for the recipe methods. And result as discussion. CML AI baseline methods results show that the table compare with scenario 1 and 2 percentage units, abiotic depletion and acidification is scenario 2 high. Other impact categories, scenario 1 high. These are abiotic depletion, ozone layer depletion, human toxicity, fresh water aquatic ecotoxicity is the agricultural land is the impact category very important. Global warming, terrestrial ecotoxicity is the important impact category. Photochemical oxidation, acidification. These are results of percentage results. Scenario 2, which hybrid system UAV in sea area. These are very fit to and economical application. This UAV experimental, and results and discussions are second section, recipe methods, human health, ecosystem, resource, the impact categories, 3 selected impact categories, scenario cultural 1, scenario 2, agricultural land and sea. The human health unit is daily. 1.71, 1.66. So scenario 1 results high. Ecosystem impact category unit is spaces for year. This results, numerical result is scenario 1, 1.05, scenario 2, 1.03. So scenario 1 is result is high. Resource units is USD 2013. Scenario 1 and 2 compare the numerical results. Scenario 2 low than scenario 1. So according to the calculated environmental effect as a result of study, the environmental effects on the agricultural land were higher than effects on the sea. And conclusions, contributing to the literature will be made by revealing the environmental effect of UAV with the hybrid power unit equipped with hydrogen fueled PEM fuel cell using LCA methods. Thus, with the developing UAV technology, it will set light to the production more environmentally, frequently, and energy efficient UAVs. Now, thank you for your attention.
Thank you very much, Mr. Çalışır, for the nice presentation on the environmental effects of a hybrid UAV with fuel cell. I think there is no question, and I have no question as well. So we can close the session now. Thank you very much for your attention and valuable contribution. So see you next time. Goodbye.
Okay.
Sesim geliyor mu?
Hello.
Hi. Can you hear me?
Yes, we can hear you.
We have a couple minutes more, so let's wait for the time. Okay, welcome everyone to our session. This afternoon's session, Sustainable Development. This is Professor Barbaros Çetin from Bilkent University. I will be chairing this session. So in this session, we have 6 presentations. One of them will be pre-recorded. So we can start our first presentation by the title of this presentation is Emissions and its Driver Analysis for the United Kingdom Higher Education Institute. So I believe our speaker is Edward Gobina. Is Edward ready?
No, Edward is not here.
Okay,
Yeah, I am
Amar Nayak
Amar.
will be
Yeah,
presenting.
I will be presenting, so I will share my screen.
Okay, so we have 6 presentations, so 12-minute presentation followed by 3 minutes question and answers will be fine. Please be careful with the time limits. So floor is yours, Anar.
Okay. Okay, so my name is Amar Nayak and I am a PhD student from Robert Gordon University, Scotland, UK. Edward and Naomi are my supervisors, so they are in the author's name. So, briefly, the introduction and the motivation. The UK built environment contributes nearly 40% of the overall energy consumption. It emits nearly 1.6 million, what is it? It's covering million tons of CO2 as compared to 351 million tons of CO2 equivalent emitted by the UK. Now, higher education institutes are looked upon as a knowledge base It has a high influence in the society, and there are knowledgeable people in the higher education institute. So that compels the higher education institute to reduce carbon emissions at the location and set up new standards and develop new methodology. So when I say higher education institute, that's equivalent to universities. Yeah. So there are, this is the introductory chapter of my PhD thesis. So this is largely the exploratory data analysis of the HEI emissions. These are secondary data, the data that is available with the governing body that looks after the emissions of the Higher Education Institute of the UK. The data is analyzed from 2014-15 to 2019-20 at aggregate level, not at the university level. I identified the factors and the ratios that are driving the emissions for the UK HEI. The study also analyzes the scope 1, scope 2 emission, its trends, patterns, and whether the HEI has managed to meet the benchmark of 43% reduction from 2005 baseline. So data and methodology part, the emissions are calculated by the formula, which is multiplying the activity data with the emission factor. Each HEI within UK records their activity data, and the emission factor is decided by the governing body. In this case, it is HESA. And for Scotland, there is another governing body, Sustainable Scotland. The reporting of scope 1 and scope 2 emission for the HEI is mandatory. They have to report those emissions with the spreadsheet. The reporting of scope 3 emission is optional, but it is encouraged because it is largely accepted that the most of the carbon footprint lies in scope 3 emission. The emissions data are available in the HESA State Department. That's where I got the data. And I have carried out exploratory data analysis, plots and visualization to understand the patterns and trends, Pearson correlation to identify the prime drivers, and some ratio analysis to see how it has improved. So these are the different factors. There are three main factors, which are building and space, energy, finance, and people. These are considered as independent variable, and the emissions and waste, which is outcome of these activities, are considered as dependent variable. And within these broad factors, there are several micro factors. For example, in emission, we have total scope 1, scope 2, volume of wastewater, and so on. So I have all listed here. So I will go through each of these factors and bit of analysis on what is the trend pattern and how the data insight looks like. So the top table is the Pearson correlation coefficient table with respect to scope 1 and scope 2 emission. I have not included scope 3 emissions here, just scope 1 and scope 2 because it is mandatory. So how to read these? These are the, on the left-hand side, I have all the different factors within the building and spaces. And on the top, I have the year for the last 5 years. 1920 is not considered because of the COVID. And the way to read this is this: higher the number, the higher the correlation. The correlation value varies between -1 to +1. 1 means it's highly correlated. 0 means it is not correlated. So in this case, internal area is highly correlated with scope 1 and scope 2. Other values are moderately or low correlated. The bottom table here is the ratio of emissions per site. Again, these are the factors, but divided by the total emission for that particular year. And on the right column, it is the improvement, how the ratio has improved over the years. For example, the emissions per ground area has improved by 43%, and the emissions per site has improved the least, which is 19%. some more visualization regarding the car space and cycle space with respect to the internal area in hectares. So as the internal area in hectare increases, the car and cycle space increases up to a particular level. And after that, the distribution is very sparse and very random. Few more stats regarding the cycle and car parking space over the last 5 years. The aggregate car parking space has decreased by 5%. In order to reduce emission, it is expected that the car parking must be penalized and the cycles parking must be encouraged. So the decrease has been very marginal, whereas the cycle space increase has been 15%. The overall emission reduction is also important to see when we analyze the ratio. The emission itself has reduced by 39%, which increases the emission per cycle space to 43%. Similarly, this is for the energy sub factor. Obviously, the energy consumption is directly proportional to the emission. So we have very close correlation, no surprises there. Apart from that, there is water consumption, which is highly correlated. Water is very energy intensive activity, pumping water, water heating in the boiler, and so on. So energy consumption and water consumption are two highly important drivers here for the HEI. Similarly, the highest improvement was seen in, it's almost same for all the factors except for the emissions per fuel used in the HE provider own vehicles, where it has actually gone down to minus 32%. The performance is, the improvement is in negative. Some visualization about the energy consumption of the HEIs at aggregate level. How to read this? This is the distribution plot or the histogram, the way we say it. Most of the energy, most of the HEI has the energy consumption less than 500,000 gigawatt hour. Similarly, most of the HEI has the water consumption less than 200,000. All these are outliers. Like there are very few universities, if you count here, this is the frequency on the y-axis. This is 2.5. So this may be probably 60% of them are outliers. Similarly, total energy consumption on the x-axis and the fuel used in HE provider's own vehicle, and energy consumption versus water consumption. This is obviously a very good relationship. We have seen that the water consumption is very energy intensive activity. This is the important factor, finance and people. All the factors within finance and people are very highly correlated with the emissions, scope 1 and scope 2, except for one factor here. The rest, all of them are very highly correlated. So the general inference would be, in order to reduce the emission, the HEI must have to decouple its relationship with the people and finance, because if the if the HEI wants to grow, they need more people and spend more money, but at the same time, they must not emit so much. So the decoupling is one of the important things that HEI must look into to reduce emission as well as increase their business. There has been few improvements here. For example, emissions per teaching income and emissions per other non-residential income. But other factors are largely improved at the same level. This is again a additional insight into all the different factors of the people and finance. I will not explain this. This is self-explanatory, how the relationship is. It's very highly correlated, as we have seen in the table. Okay, these are the important stats. I have 4 tables here. The top left is total emission. Top right is minimum emission, how the minimum emission has reduced. bottom left is maximum emission, and the bottom right is mean and median emission over the 5 years. And the y-axis is the same as the scope 1 and scope 2 emission in megagrams. The total emission has reduced over the period of 5 years. So is the minimum and maximum. That gives the range. And this gives the, basically it gives the statistics of mean, median, range, and the total value. It looks good just by looking at the figure that everything is reducing. But if we look at the benchmark was to reduce 43% by 2020 from 2005 baseline year. So this is 2005 baseline year. Emission was this much. In 2014-15, it actually increased by 10%. And only in the last 5 years, it reduced by 33.7%, which is way below the 43% reduction required to meet the target. Now coming to scope 3, whatever I talked now was for scope 1 and 2. Coming to scope 3, the scope 3, what I observed from the data is only 0.4 to 0.5% of the scope 1 and scope 2 emission, which does not sound right, because based on the literature, the scope 3 emission must be quite big as say 50%, or probably more than that. But the main reason why it is low is because the HEI reports only 3 kinds of source of scope 3, whereas there are 15 different kinds of scope 3. Especially the procurement and the emissions due to travel are the largest contributor, which are not reported here. So that's why the proportion of scope 3 looks very small in this case. This is the benchmark plot. On the x-axis, it's again a distribution plot of how the HEI has reduced their emission. So if we look here, the 43% is what is required, but there are the HEI on the right-hand side are the one that has achieved the 43% and the HEI on the left-hand side are the one that has actually not achieved, and the HEI less than 0 is the one that has actually increased their emission. So the mean is right now at 35%. What we wanted was 43% and above. So the summary is, at the aggregate level, HEI has failed to meet the target of 43% reduction. At present, the status is around 33.7% reduction. Only 48 out of 135 HEI has managed to reduce the emission by greater than 43. And majority of the HEI, it's less than 43, and some of them have actually increased their emission. So 64% of the HEIs that reported emission for the 2005 is unlikely to meet the target of 43% emission. And scope 3 emissions are not mandatory, but it is encouraged. So only 3 different sources of emissions are reported right now. So that is why the comparison of scope 3 emission at this stage is not so great. Okay, so that's my presentation. Thank you.
Okay, Amar, thank you for your nice presentation. Any questions from the audience? If you have any questions, you can also write on the Q&A answer chat box. I can also read the questions from there. Okay, for the sake of saving the time, let's move to our second presentation. Thank you, Amar, one more time.
Yeah, no problem. I will cancel my screen share.
Okay, our next presentation is evolution of microclimate effects of an urban park over their built environment. And I believe the presentation will be given by Maria Angelica Ruiz. Maria, are you ready?
Yes, I'm ready.
Okay, you can share your screen and you can start right away.
Okay. Can you see my
we are about to see it, I guess.
Okay. Good afternoon.
It is still black, but I hope it will come.
Okay, okay. Good afternoon for everyone.
Yes,
thanks for introducing my presentation. My name is Angelica Ruiz. I am agricultural engineering and doctor in renewable energies, and I work for INAE CONICET in Mendoza, Argentina. I'm going to present my paper title. I'm going to present my paper title, Evolution of Microclimate Effect of an Urban Park over the Built Environment. I did it in cooperation with my partners, Florencia Colli, Doctora Claudia Martinez, and Doctora Erika Correa. Greening, it has been previously studied that greening is an efficient strategy for the adaptation and mitigation of the urban headland and urban warming. Parks, urban parks from the cold parcel island, which can effectively alleviate the negative influence of urban headlands. However, it is important to highlight that in arid zones, the greening demands a certain amount of water in a place where this resource is scarce. For this reason, it's necessary to plan the features of built-up areas around the park in order to guarantee their sustainability in terms of management, natural resource consumption, and thermal benefits. Thus, the objective of this work is to evaluate the impact of Parque Central in the city of Mendoza, Argentina, on the air temperature of its built environment, taking as a measure the intensity of Parque Island. In addition, we analyzed the evolution of its cooling effects over 10 years in relation to the evolution of the park and the surrounding urban areas characterized by means of satellite image indices. Well, Mendoza's Parque Central is the fourth green space on the surface of the city. It has an approximate area of 14 hectares. It is the northwest of the city, here, in a residential area with medium to high construction density. It has a strategic value for urban development, given the numerous uses and artistic, sport, social, and cultural activities provided. Since its creation in 2006, several of the specimens incorporated did not adapt to the environmental conditions of the growing site. At present, the most tolerant have been consolidated, integrated, forested, or aligned groups with the development of a dense vegetation cover, the canopy, that provides important shading. Two monitoring campaigns were developed during the summer periods of 2007-2008 and 2016-2017. Temperature and relative humidity sensors were installed, recording every 15 minutes. Two of them were located within the park in well-differentiated structures, meadow and forest. In addition, 4 sensors were installed around the park at an average distance of 450 meters from the edge. Finally, a sensor was located in the center of the city. Landsat 7 satellite images from 2008 and 2017 were analyzed in order to study the evolution of the green areas and their surrounding and evaluate the microclimatic behavior. 2 indices were determined: normalized difference vegetation index, you can see in the images, and normalized difference building index. The QGIS software were used to process satellite images, and the definition of our hourly PPCI is the difference in air temperature between the surroundings, urban areas, and the park, as you can see in the formula. The results show that NDVI increases from 2008 to 2017, which denotes the consolidation of biomass. But during maximum temperature occurrence at 5 p.m., the maximum temperature differences between park and surroundings decrease after 10 years. The gray bars in 2008 reached almost 4 degrees. And in 2017, they do not reach 2 degrees Celsius degrees. This reduction shows the impact of urban growth throughout the period evidenced by NDVI. In the table, you can see that the quantity of built-up areas has increased from 2008 to 2017. The maximum values of NDVI have increased in a range of 1.5 to almost 2 times. But the cooling effect not is homogeneous. In the south point, the variation of the maximum NDVI has been the lowest, whereas the cooling effect caused by the park is the greatest. On the contrary, the east point shows the highest increase in maximum NDVI and the lowest cooling effects. Based on Garcia Aro et al. Results, the cooling effect of the park would be expected to increase with the NDVI increase. However, this has not the case, demonstrating that the thermal benefits of the park have been governed by the densification of its surroundings. As the building mass increases, the thermal inertia of the environment increases as well, and temperature differences with the forest decrease in the hours of sun. The cooling effect of the forest is more susceptible to increase of NDVI than that of the middle. Respect to the Park Rhode Island, during the 2007-2008 season, the maximum PCI, the pink bars, show that the maximum PCI is 1.3 degrees, being relatively stable throughout the day. During the 2016-2017 summer, the maximum values of PCI, the red bars, occurred during the noon. The park is up to 3%. The park is up to 3 degrees Celsius degrees colder than the around the surroundings. In conclusion, I can say that this research highlights the challenges of reconciling the thermal benefits of an urban park placed in an another zone with the environment growth. The forest structure is 57% cooler than the surroundings in 2016 versus 2008. In contrast, the maximum PCI recorded between the middle structures and its surroundings represents a 62% increase in its cooling effect. Over 10 seasons, the park's maximum NDVI has increased more than 8 times, while the maximum PCI intensities have increased 2.3 times. The high increase in vegetation is not directly proportional to the cooling effects of this urban park. The cooling profile of the park has changed. The NDVI and PCI grew, but the evolution of the surroundings has modified the role of the park as a thermal regulator. The thermal benefits of the park has moved from the night to the afternoon hours. Finally, this work has shed light on the understanding of the roles of landscape inside and outside parks in PCI features. Well, the reference can be found in the paper. And I leave my mail for any questions and a pre-pandemic image of the Mendoza Parque Central. Thank you very much for your attention.
Thank you for your presentation. Any questions from the audience? The findings are really interesting. Okay, I believe we don't have any questions. Okay, we can move to our next speaker. Our next presentation will be pre-recorded.
Sorry, may I have a question to Maria?
Okay, yeah, Elena, please go ahead.
Thank you.
Hi.
Maria, thank you very much for letting me asking. What species did you could you see in the park? What are the main species at the park? Thank you.
So, sorry, you can repeat the question?
What are the main species of plants in the park? Thank you.
Okay. The main species are Schinus moreira, Populus species, Platanus species, Platanus I don't remember the specific studies. In the 2006, when the park was created, they planted many species that no are of air zones, and they aren't sovereign. But there are several species in the park that species were changed, and they are sovereign and consolidated with along 10 years.
Thank you very much. I probably can see the details in your papers. Thank you.
No, thank you for you.
Okay, thank you. So the title of our next presentation is Analysis of Urban Scale Energy Certification Systems for Efficient Communities. And that is a pre-recorded presentation. I believe our IT people will play the video.
Hi everyone, I am Maria Belén Sosa, a PhD researcher at the Institute of Environment, Habitat and Energy in Argentina, from Mendoza, Argentina. Today I'm going to present our work titled Analysis of Urban Scale Energy Certification System for Efficient Communities. Cities worldwide will demand 40% more energy resources by 2030. This projection is preoccupying since in general terms, cities have not been planned considering the energy they consume or how the increasing cost of the scarcity of this resource can affect our development. The energy efficient on building scale is a topic commonly approached by the scientific community with several studies and application cases. However, this trend does not have been reflecting at the urban scale at the same magnitude. In this sense, working on the intermediate scale of a city, neighborhood, or communities surpasses the analysis of buildings as units and of the city as a whole. The present work was developed based on three main objectives. Number one, analyze the categories considered by the most widely used and implemented urban scale certification systems. Number two, detect the system that considers the urban form energy consumption relationship between the categories. And the third, apply the system to a group of cases in the study area of Mendoza, Argentina, and verify if the certification system is consistent with the result previously obtained from the urban form energy consumption relationship. At international level, there are several certification systems that have been developed and adapted their version to urban scale. Between this group of certification systems, the most widely used worldwide were analyzed. This condition was determined by counting the number of certifications granted to date for each system in its urban scale version, taking as a cutoff line those systems with no more than 10 certifications granted. The analysis and contrast of the categories considered in the selected certification system was the next. Each system evaluates the communities by category according to a checklist that gives a final score and the certification level achieved. These categories, with the associated credits of each system, were systematized in a spreadsheet. With this information, the percentage weight of each category in each system was determined. It is important to clarify that in order to make a fair comparison, the total credit of each system were normalized to 100%, since there are variations between them. Here are the results of this first main objective, where we can see LEED, BREEAM, Cadre, and Green Star, all that certification system at neighborhood or community level. Okay, BREEAM In BREEAM, the 37% correspond to the category social, economic, and environmental well-being. This category seeks to increase the level of habitability, well-being, and health of the public space, guaranteeing a social cohesive community. LEED has the also 37% corresponding to the category neighborhood pattern and design. This category prioritizes efficiency in the use of land and transport with compact urban form of mixed use designed for pedestrian traffic with trees in the streets, parks, and squares, encouraging them to be a socially equitable and participatory neighborhoods. Green Star, the 37% correspond to the category environment. This category focuses on incorporating strategies to reduce the ecological footprint of infrastructure, transportation, and buildings in a community through a life cycle analysis. And in CASB, the 36% corresponds to the category emissions to the environment. This category focuses on reducing the CO2 emissions from buildings to the environment. Okay, this analysis shows us that LEED places greater importance on the urban form planning, which is one of the objectives of this work. Okay, now objective 2, with this information, the design parameters determined by the selected certification system were applied to 3 neighborhoods of Mendoza, where energy performance is now empirically from previous studies. These neighborhoods were monitored microclimatically during the summer. They were adjusted in MBMed simulation software, and with the output data, the estimation of energy consumption was made considering only the performance of outdoor spaces for the summer conditions. Here we have a graphical view of these neighborhoods, of these urban pattern neighborhoods. These 3 neighborhoods represent the typical urban development model of Mendoza metropolitan area of Argentina and respond to 3 types of pattern: rectangular, multisimultaneous, cul-de-sac. The urban characteristics are residential and commercial use, 20 meters wide street forested with second magnitude trees, 3 meters wide sidewalks, and 3 meter high single family homes with homogeneous designs and materials. The result of this application shows us that the requirement of LEED neighborhood pattern and design to the 3 neighborhoods doesn't show a direct relationship between the credits achieved and the energy consumption estimated. This is because the requirement partially contemplates the variable related to urban form energy consumption relation. This consideration is verified by observing the result obtained between the cul-de-sac and the rectangular pattern. Both forms reach the same amount of credits, 34.5. Also, the energy consumption is different at neighborhood scale. Our findings show us that certification systems are a first step to categorize a community. From the point of view of assessing the design of urban form in relation to energy efficient, LEED system only considers partial aspect of a general nature. Its regional application requires considering variables associated with the implantation site and microclimatic context, as well as a specific aspect regarding the urban form that significantly impact in energy consumption, in particular related to the urban canyon profile, the configuration of shadows in terms of warranty homogeneous distribution. In future stages, we expect to give continuity to this theme in order to make a local contribution associated with the development of a certification system that depends approach related to the design of the energy efficient urban form, taking LEED system as a methodological reference. Thanks a lot.
Okay, we would like to thank the authors for the presentations. Unfortunately, since it is pre-recorded, we don't have the chance to ask any questions. So I believe we can move to our next speaker. Our next presentation is bioclimate of urban areas at the Russian far north in the context of climate change, energy and human health. Our speaker is Elina. I believe Elina is ready. So you can start if you are ready.
Thank you very much for introducing, and I will start with my presentation. Let me share the screen. Just let me know if you can see my screen.
Yeah, we can see it, no problem.
Yes. And I'm Elena Grigorieva from the Institute of Russian Academy of Sciences at the far east of Russia, that is quite far from Moscow, close to Japan and China. And my main research topics are climate, applied climate. That means climate mostly for human health and climate for agriculture. And today I will talk about a bioclimate of urban areas at the Russian far north. That is a really very important issue. The reason is that the extreme north or far north of Russia is a very large part of the country located mainly on the north from the Arctic Circle. Its total area comprises about 1/3 of the whole country. The southern border of the far north passes in the European part of Russia and in Western Siberia, about latitude 62 north, in Eastern Siberia, latitude 60 north, and in the Russian Far East, latitude 55 north. This part of Russia is located in a very harsh environment characterized by extremely low ambient temperatures. Cold climatic conditions are combined with high air humidity and strong winds, which sharply aggravates the effect of low temperatures on human body and its thermal regulation system, as well as worsens human health and well-being. The current study is aimed at assessing changes in the outdoor thermal environment in urban areas of the Russian extreme north from the point of view of energy supply for human health and well-being using bioclimatic indices. Many bioclimatic indices are designed to display the complex influence of climate and weather on thermal discomfort, which are used for both cold and warm environments. Some of them are designed for both seasons, that means for the whole year around. Mainly, these indices are designed on the basis of parallel physiological and meteorological observations, and they use both conditions of thermal environment, temperature, humidity, wind speed, solar radiation, and those characteristics from the person, that sweat evaporation, respiratory heat loss, internal heat production, clothing insulation, and others. To determine the level of thermal load of weather and climate as a whole on the human body or the risk to human health, special bioclimatic indices are used, which characterize the ambient thermal environment in calorific terms, showing the energy supply or deficit of ambient conditions. And now I will show the application of two of these indices. One of them that is used mostly in Russia and the former USSR countries, the hill wind wet cooling index, widely used for bioclimatic studies for both cold and warm period. And it takes into account air temperature, air humidity, and wind speed at the upper side of this slide. During the cold season, when hill index is higher than 70, it characterizes absolutely discomfort conditions. And we can see later that it's the case for the Russian far north. Another index is wind chill index, indicates thermal sensation of temperature enhanced by wind speed. So in this index, we are looking on temperature and the wind speed. It is used for estimation of possible hypothermia. A person dressed in winter clothing is hypothermized at a very specific level of this index, and if it's higher than 2500, it means intolerably cold. Estimations of spatial and temporal dynamics of the thermal discomfort was carried out for the main urban areas of the Russian far north, including 9 cities, and among them Surgut is the largest city, Norilsk is the more northern city, and Petropavlovsk-Kamchatsky is more southern at the Russian Far East city. The average monthly and yearly data on air temperature, absolute humidity, and wind speed for 2 periods, 1960-1990, and from 1980 till 2010, presented by World Data Center in Obninsk were used. And here at this slide, you can see the data for the second part of this research period. And we can see how low temperatures can be in Yakutsk, and these are mean monthly data up to 40 degrees, minus 40 degrees in January. That means that minus 55, minus 60 weather data are not rare. But in summertime, temperature can be as high as plus 20 degrees in July. That's Yakutsk, but looking at the severity of climate, we can see later that it can be much higher, more severe climates in other cities when temperatures are not as low. In January, according to Hill Windward Cooling Index, all cities are located in a severe cold zone with index much above 50 in category of extremely discomfortable conditions, and absolutely discomfortable are indicated in Norilsk with 88 in January and 83 during the cold season. Vorkuta and Magadan have the same thermal harshness during winter, near 75. But looking now back for Yakutsk, it has much lower values of thermal discomfort, is expressed by Hill index near 50. Even these values are still characterized by extremely discomfortable, but they are much lower. That is explained by calm conditions with the wind speed near 1 meter per second. And in other cities, it can be as high as till 10 meters per second. Wind chill index shows that outdoor climate is extremely and intolerably cold, with values for the period from January to February higher than the threshold value for the whole year. In Vorkuta and Norilsk, it's observed during months from November to April. Extreme values of wind chill index have the same spatial distribution as Hill index estimation. During months from June to September, that is summertime, wind chill index indicates comfortable conditions everywhere in the cities at the Russian far north. Now, just as an example, another indices that are expressed in degrees centigrade, they have the same estimation of temperature, air humidity, and relative humidity. And we can see that differences between a real temperature and perceived temperature, that means temperature that combines everything, relative humidity, wind speed, and real temperature, can be up to 30 degrees. That you perceive much lower temperatures than it's in reality. Let's say in real time, it's minus 20, but you feel it as minus 50. It's really very discomfortable. The effect of cold environment aggravated by strong winds can be expressed on human health directly, damage to extremities, chills, frostbite, cooling trauma, and indirectly, an increase in respiratory and cardiovascular morbidity, particularly in more sensitive to weather influence groups, children and elderly. And you can see here a picture of myself that showing that it's better to cover your face as much as it's possible, otherwise it can be frozen. And special plans for cities should guarantee safety of people, especially for those who work outside. High calorific food, proper clothing, insulation, working regimes, and others should be really at these plans. Climate change is objectively manifested in ambient temperatures up to 2 degrees in mean year values and up to 4 degrees in January for Yakutsk, that is the coldest city. Despite the increase in temperature, climatic discomfort expressed by bioclimatic indicators in calorific terms particularly does not change, remaining in the same grades of thermal extremity throughout the year. And as conclusion, bioclimatic indices Hill, wind wet cooling index, and wind chill temperature express cold environments in cities at the Russian far north regions in calorific terms. Generally, northern cities with low temperatures and strong winds are more discomfortable, especially in January. No obvious changes in thermal extremity is found due to the growing temperature in 2010 compared to 1960-1990. Cold environment cause direct and indirect impact on human health, manifesting itself in an increase of respiratory and cardiovascular morbidity. And thank you very much for listening. And just very short in conclusion, as Vice President of International Society of Biometeorology, let me introduce you this society, which provides an international forum for interdisciplinary collaboration between specialists of different specialties, meteorologists, health professionals, biologists, climatologists, ecologists, and others. It consists of several commissions. I'm part of Climate and Human Health Commission and Climate, Tourism and Recreation Commission. And we have International Journal of Biometeorology, published by Springer, and it's a pretty high score in Web of Knowledge. And welcome to our society. Thank you for listening.
Thank you very much, Elena, for this nice presentation. Any questions from the audience? So I believe we can conclude that the north part of Russia is very cold. That is the take-home message.
Thank you.
Okay, thank you very much. Our next presentation is production of pan-packed thermal energy storage nanofibers by electrospinning method. And our presenter is Timur Paçacı. So, Timur, if you are ready, floor is yours.
Yeah, I'm ready. Thanks for your introduction. Sharing survey. I cannot find shavings in survey. More recordly. Okay. Are you seeing?
Yeah.
Oh, okay. My name is Timur Paçacı. I am PhD student in Tokat Gazi Osman Paşa University in Turkey. Our title is Production of Polyacrylonitrile Polyethylene Glycol Thermal Energy Storage Nanofibers by Electrospinning Methods. Thermal energy storage is considered as one of the important technologies for energy recovery in the future. There are three types of TES. These are sensible heat storage, latent heat storage, and reversible chemical reaction heat storage. Among these, actually, we will consult with the PCM. Most organic PCMs like paraffins, fatty alcohols, low malic acids, and polymers correspond to a majority of these properties. They are also very grateful for thermal comfort applications. In order to solve the energy handicaps and improve functionalities, scientific PCMs have attracted considerable attention in the last few decades. And the other part, the important part, is nanofibers. Nanofibers are a kind of nanotechnology products. They have superior properties compared to traditional microfibers. Nanofibers provide important opportunities for industry in their large surface area. The important point here, large surface area, and there are other structures. In addition, nanofibers can be used in many different areas. Polyethylene glycol is used as a solid-solid or solid-liquid PCM. In the literature, there are lots of polyethylene composites as PCM for latent heat energy storage. In this study, the aim is to obtain a non-leaking and reusable product by placing polyethylene glycol with high latent heat storage properties into polyacrylonitrile nanofibers. In this way, polyethylene glycol, which turns into liquid form by taking heat, will be stored in nanofibers with high surface area without showing leaking behavior and will gain reuse features. To analyze nanofibers, scanning electron microscope, differential scanning, calorimetry, and history were used. Our materials generally mercury and polyethylene glycol, dimethylformamide, and polyacrylonitrile are chemicals, and our devices NOVA data logger and Polyscience Mark-Sire batch and electrospin device. Our method, you see the picture of our method. Firstly, we prepare a mixture polyethylene glycol 2000 and polyacrylonitrile and dissolve this in DMF. Later, we filled the syringe with our mixture and we apply big voltage. This voltage is generally 10-20 kilovolts. And we collect it here and we cover this aluminum foil. Experimental results, electrospin conditions, these are our optimum conditions. When the voltage rises above 20,000 voltage, the scattering increases. And when the distance drops below 15 centimeter and rises above 20 centimeter, nanofiber formation decreases. In addition, when the pump volume exceeds 1.5 milliliter, drops begin accumulate at the needle tip. So the optimum conditions, you are seeing now optimum conditions. DSC results. DSC analyses were obtained by NECH DSC 214 polymer model instrument. You see graph. This graph is temperature versus millivolt actually, and this area is melting enthalpy. This area is crystallizing enthalpy. You see the green one is 35% polyethylene glycol. The red one is 20, and the dark blue one is 10% polyethylene glycol. And this straight line is polyacrylonitrile, and polyacrylonitrile actually don't have any enthalpy values. You see the values actually, according to DSC results, while polyacrylonitrile did not give any melting and crystalline enthalpy value, 35 polyethylene glycol 2000 showed the highest melting and crystalline enthalpy. In addition, as the polyethylene glycol ratio increased, an increase was observed in the melting and crystalline enthalpy. You see the table. These enthalpy values are high enough for usage because polyethylene glycol 2000 melting enthalpy is normally 173.5 3 joule divided 1. And we stored nearly 70% of melting enthalpy of polyethylene glycol by using 35% polyethylene glycol 2000. This graph derived from the SD results. This is total enthalpy temperature graph, and you see the total enthalpies respectively. Similar results were recorded for cooling enthalpy. This part is heating enthalpy, heating total enthalpy, and this part is cooling total enthalpy. T-history, actual T-history gives us the behavior and sustainability of the material against heat. So you see the picture of the T-history system, 0 to 70 degrees. This is data logger, and this is a water bath. According to T-history results, this graph is belong to T-history results. Materials show similar behaviors during heating and cooling periods. So this is the evidence of sustainability of materials. In other words, polyethylene glycol melted, melted at 20 degrees, did not show any leakage behavior in the range of 70 degrees. Our SEM results, A and B are polyacrylonitrile magnifications, polyacrylonitrile images. C and D, 10% polyethylene glycols. You see models, actually these are polyethylene glycols. These zones are polyethylene glycols actually. And the thickness of our nanofibers decrease when we add more polyethylene. We see the similar results. E and F is 20% polyethylene glycol. G and H are 35% polyethylene glycol. When, according to SEM results, while polyacrylonitrile provides very good nanofiber formation, we see the image. Polyethylene 2000 was located in the form of models between nanofibers. The higher the polyethylene glycol percentage, the higher the models formation. In addition, as the polyethylene glycol ratio increases, the thickness of the nanofibers decrease. As a result, optimum conditions for formation of nanofibers are 15, 18 centimeter, 15,000, 18,000 voltage, and 1.2, 1.5 milliliter for distance, voltage, and pump volume respectively. According to DSC results, as the polyethylene glycol 2000 ratio increased, an increase was observed in the melting and crystallization enthalpies. In addition, maximum 75% latent heat capacity of polyethylene glycol was stored in nanofibers so that it's enough for PCM applications. According to T-history results, materials did not show any leakage behavior between 0 and 70 Celsius. According to SEM results, the higher the polyethylene 2000 percentage, the higher the modus formation. As a result, polyethylene glycol 2000, which turns into liquid form at 20 degrees, would be stored into nanofibers with high surface area without showing leaking behavior and would be gained reuse features. And these are nanofiber pictures. Thank you for your attention.
Okay, thank you, Timur, for the presentation. So any questions from the audience? Okay, I think we can move on to our next speaker. Our final presentation is a new methodology for distributor selection in refrigeration cycles. And our speaker will be Habib Akın Hacı Musalar. So Akın, if you are ready, you can share your screen and the floor is yours.
Okay, I'm ready. I will be sharing in a moment. Okay, So do you see my screen now?
Yeah, that's okay. You can start.
Okay. Hello, my name is Habib Akın Hacı Musalar. I have just graduated from Marmara University Mechanical Engineering Department. Today I will propose my graduation topic, which is a new methodology for distributor selection in refrigeration cycles. The project was conducted with university-industry collaboration. So hereby I would like to acknowledge Free-Term Company by your presence. So in today's world, energy plays a crucial role. We encounter the application of energy systems all over us, from the lightnings of our homes to providing megawatts of energy to enormous facilities and power supply activities. A wide application of energy also welcomes us on heating and cooling cycles. Vast types of cycles exist, and we may encounter these cycles from our refrigerator in the kitchen to even cool down our water in these hot summer days, even military-based cooling activities. So by having such enormous use of cooling activities, we start seeking for increasing efficiency and overcome the obstacles that exist during heat removal processes. And one of the possible ways of increasing efficiency is having a suitable distributor selection. So distributor takes place between expansion valve and evaporator, and it aims to satisfy two-phase homogeneous flow distribution. And the phase is gas liquid mostly. Here you can see a drawing of distributor. The flow, two-phase flow, enters the distributor from that way, and with these tubes, it reach evaporator tubes. So why we need to pick a suitable distributor? By selecting the right distributor, we may increase the efficiency of our refrigeration cycle, because suitable selection satisfies homogeneous flow distribution. And also it avoids hunting and maldistribution due to non-homogeneous and fluctuated flow through evaporator tubes. The motivation of the project, the exit point of the project is come from the usage of the old methodologies in the industry. So these old methodologies, they may not give accurate result always. So due to non-accuracy between theoretical and experimental pressure drop, we begin to focus on such project. Also, existed methodologies, existed softwares, they do not consider important features, and their features are limited, which I will be talking about these features later on. So the aim of the study is developing a commercial software that yields reliable pressure drop calculation. So why this is important? Because having an accurate pressure drop prior to experimental setup or refrigeration cycle design, the user may need to reconsider the design that he or she made. Accurate knowledge of theoretical pressure drop to experimental setup refers this idea. Also, extending the features given by the software is an important issue. Also, we seek to eliminate efficiency loss due to non-homogeneous distribution. So the question is how we are going to do that. How did we achieve that? So in order to propose this methodology, application of two-phase pressure drops are examined. In refrigeration cycles, pressure drop has three subcategories, and these are gravitational pressure drop, accelerational pressure drop, and frictional pressure drop. So since we are dealing with horizontal tubes, we may neglect gravitational pressure drop. Also, due to having a general formula on accelerational pressure drop, this is not the case that we focus on. But the problem occurs at this section, frictional pressure drop. In order to overcome non-accuracy at frictional pressure drop, this methodology is developed. Consideration of flow pattern and integration of regime map. So existed commercial softwares, they do not consider flow pattern and regime map. But since we are dealing with two-phase flow, regime of the flow is very important to us. So the flow can be annular, bubble, slug, and these regime affects friction factor in the evaporator tubes. So by focusing on the regime map, we developed a better friction factor. So we increase the accuracy of the process. For this purpose, we used the map, which is developed by Title and Dockler in 1967, is used. This is a 3 y-axis map. The axes are KD, FD, and TD. They're all connected to each other, but since this is an old map, we consider the one which is developed by Cionciolini in 2016, and we integrated this map to proposed study. So another novelty is subcooling and superheating extension. So existed methodologies, they do not consider subcooling and superheating, but these are common activities in the industry. So by having such extension, we give user new areas. We give them more freedom. And user-defined tube wall thickness assignment. Also, as well as subcooling and superheating, existed methodologies, they do not consider tube wall thickness. So with this study, there's a dependent tube wall thickness input is exist, and user can consider this feature as well. Also, ability to see intermediate information such as Reynolds number, density of the two-phase fluid, viscosity, mass flow rate, volume flow rate, and etc. So here, an interface of the software is given. This is the section that I mean new features that I mentioned here, ability to see intermediate data. Subcooling, superheating parts are also existed here. This is the interface of the software. So the validation of the study. To validate the study, 5 different cases are examined in laboratories of Free-Term Company, which is industrial corporate of the methodology. Experiments are taken via R404A refrigerant, and each of these cases are repeated 3 times. Also, to eliminate the most suitable and accurate validation process, subcooling and superheating conditions are also studied. Here, you can see what types of result we observed during this development. Here, you can see the case numbers, experimental outputs, which is the average values of these 3 times repeated cases, what pre-existed methodology offer, and what proposed methodology offers. Here also error bars are given. So if we read case 1, experimental data is 72.14 kilopascal. So pre-existed methodology made calculation with 12% of error, while proposed methodology made the calculations with 5%. So in these 5 cases, if we compare the errors, pre-existing methodology's error percent varies between 1% to 40%, which is huge, which is pretty big period, let's say. But what we proposed is up to 16%, and it is pretty much accurate. Here you can see the plot of experimental data, pre-existing methodology, and proposed methodology. These bars represent error bars. So in these 5 cases, only in the third one, proposed methodology was not in the range of 5% error, but for the other cases, the results are pretty good. And as you can see, pre-existent methodology, which is given in the yellow color, is pretty away from the points that it's supposed to be. So to sum up, with this methodology, with this study, new pressure drop methodology has identified evaluation of pressure drop at evaporator tubes are studied. Accurate and convenient output is observed. New features are added with new extensions, and efficiency loss due to non-homogeneous refrigerant distribution is minimized. Here you can see the references that I used. Thank you for your time. Here is my contact. If you have any questions, I would be pleased to answer.
Okay, thank you, Akın, for your nice presentation. Any questions from the audience? Okay, so actually I have one comment about your results that you gave in the table a couple slides back.
Yes.
So I think it will be nice to add your uncertainty with your experimental result in this table also. We see the error bars in the figure, but the errors are not given in this table. And one minor point, Akın, so if you represent the experimental data with 2 decimal points, like the one in 72.14, it means you are confident about this measurement up to 2 decimal points. As far as I know, measurement of a pressure, you cannot measure the second decimal point with a confidence level, with a high confidence level. So just be careful about while you are presenting your experimental results. That will be my comment. So my question is, after those comments, is this software will be available, or is that gonna be the property of the company?
Okay, at first, thank you for your contribution. I will be considering what you said about the experimental data. The software is, at this moment, it is for the company. So if the company offers to make it commercial, we can focus on making software, which is also available for other companies as well, and industry as well.
Actually, we will apply to, okay, once you do the patent application, my advice would be you can make a lighter version of this software and you can put it on MATLAB download center, MathWorks download center. If you just switch it to MATLAB, in that case, that's a very popular platform. There are lots of softwares over there and people are downloading and use it. At least for academic purposes, you can put one version over there because you may get feedback about your software and for the future steps.
Yeah, thank you, Mr. Çetin. Actually, the study is also held via MATLAB environment.
Yeah, in a MATLAB?
Yes, yes.
Yeah, okay, then you can directly upload it on MathWorks download center so that everyone can use it. Maybe you can upload a lighter version. Maybe the much more complicated one will be commercial, but a lighter version can be there for free.
Yes, maybe we can cancel some important features such as regime map or new extensions. And lighter version might be free, but patent, there will be an application for patent will be held, so we will see.
And you need to be careful. This presentation is also recorded and you already present this. So in your patent application, the data shouldn't be presented anywhere. Just a small comment for you.
Yeah, actually, I just would like to show a lighter version of the software interface. So I hope it won't be a big problem.
Because I have the similar experience. We are developing a software about HVAC with Aselsan, and we are about to upload it on MATLAB, and we did the patent application, so on and so forth. So I know the procedure quite well. So just be careful about that. Okay.
Yeah. Thank you. Thank you for your kind comment.
Yeah, nice work. Thank you very much. So if there are no further questions, I think that is all for our session today. I would like to thank all the speakers for their contribution, all the attendees for the questions, and we can conclude our session at this point. Thank you very much.